There seems to be a new paradigm that's emerging that's basically changing our view of the universe from something that was random and arbitrary towards a system that has this non-arbitrary evolutionary trajectory such that the universe grows more complex and such that information accumulates in the universe and the universe organizes itself in a way such that these conscious agents arise. Not only that, but the networks of conscious agents seem to get increasingly robust as they learn, such that it's really, really hard to kill life, which makes this sort of tendency towards higher complexity, which drives the spread of life, inevitable because the system just gets more and more robust. It's just this learning process, just like training an AI.
Welcome to Living Mirrors with Dr. James Cook. My guest this week is Bobby Azarian. Bobby is a science journalist and cognitive neuroscientist who received his PhD from George Mason University. He's written for publications such as The Atlantic, New York Times, BBC, Scientific American, Slate, HuffPost, Quartz, and Aeon, and he writes the blog Mind in the Machine for Psychology Today. His recent book is called The Romance of Reality: How the Universe Organizes Itself to Create Life, Consciousness, and Cosmic Complexity, all topics that we talk about today. I hope you enjoy the conversation. Okay, I'm here with Bobby Azarian. Bobby, thanks for coming on the podcast.
Thanks for having me, James.
Yeah, great to have you here. So we're going to be talking about the work you've been putting forward in your book, The Romance of Reality. But from our correspondence, I get the impression your headspace at the moment is you're also kind of very much looking forward to the kind of future projects. And Romance of Reality covers a lot of ground, and the possibility of talking about stuff that you're thinking about now for future stuff expands that ground as well. So there's a lot of detail we could dive into. I'm tempted to kind of offer you the space to begin with, to kind of, if you can, lay out an overview of your thoughts and Romance of Reality, and also where you're thinking of going next. And that may be a kind of an impossible task, but I'll just give you the floor to give us a feel for where you're at.
Okay, yeah, and feel free to talk about your theory, like in relation to mine, or contrast similarities, because I know we have a lot in common, and that you have a well-developed consciousness theory, and we differ on a couple of issues, but I think overall it's pretty much the same picture. So yeah, don't feel like you just have to interview me about my thing. Feel free to talk about your theory, because I watched some videos on it, maybe like when you first reached out to me. I don't know if it's been a year by now, but yeah, I thought it was really fascinating stuff. And but I would need a little bit of a refresher on it as well.
Right. Yeah.
So to give an overview of The Romance of Reality, and then I will, as you said, kind of relate it to what I'm interested in now, which is really taking the ideas in that book and kind of applying them to life and to how they can help society, and how they can inform us, I guess you could say, like spiritually. But basically, the book, I wanted to present a solid argument for the sort of hypothesis, you could call it, that I'm proposing. And I wanted that to be convincing to scientists. So I wanted to explain the mechanisms underlying the phenomenon that in sufficient detail, such that scientists and science-minded people would be convinced by the argument. Because if you don't make a convincing argument and you're making these big claims, which, I'll lay out those big claims, because, and I'm not going to like tiptoe around what those claims are, which I've kind of done in the past, because they are massive. You can't get any bigger than these claims. But if you're going to make those kinds of claims and you don't have a good mechanistic explanation for why things are that way, no one's going to believe you, and they shouldn't if you don't have any support, any real meat to back it up. So that's what the book focused on, was making this strong scientific argument for some pretty radically different claims about the nature of existence. And what the next book is going to be about, and what the posts on my Substack are pretty much about, and the Substack's called Road to Omega, is about, basically making those ideas practical, and that uh, those bigger, those applications of these ideas, like to life and to society, uh, they're only hinted at in the book. But all of those things that I'll be talking about, the seeds are planted in the book. But really, it was just focused on the more technical issues. So, anybody who's interested in the technical side of things can check that out. And yeah, because I won't be able to go into so much detail here. And there's lots of other talks online. But the basic premise of the book is that the universe is a self-organizing system. And by that, I mean, we hear this story of the universe being made of these fundamental particles, and we hear about theories of everything and trying to explain the universe in terms of science. It's usually thought about, explaining it in terms of physics. And we have these so-called theories of everything, which are basically theories about the fundamental particles in nature and the forces that allow those particles to interact. But what we don't hear about in those theories is emergent phenomena. So life, mind or consciousness, culture, those things are left out of the picture because they're assumed to not be important. It's just a story of particles following these determined mathematical trajectories like pool balls on a table. So if that's the case, there's no room for consciousness to have any sort of causal power on the world. So it's not really important. It's considered what's called an epiphenomenon. So epiphenomena are basically there's something there that has emerged, but there's nothing fundamentally new. So the particle level description includes everything you'll ever need to like understand the system. And so basically that explains away consciousness and psychology and sociology and economics. If we understood according to like the kind of old version of determinism, where the universe is just this particle world that follow these simple trajectories, basically Newtonian trajectories, you could, in theory, calculate the trajectory of, the future of the universe without any reference to, living things. And so the book basically says that's wrong. And it basically says that the universe is organizing itself where the components come together to make higher uh, complexity structures. So, fundamental particles like quarks come together to make atoms, which come together to make molecules, which come together to make cells, which come together to make multicellular organisms, which come together to make societies. And the whole biosphere seems to be this interconnected network of these different systems that are all arranged in this like interconnected network. And there's this nested hierarchical structure. So what I'm saying is that's not a fact. That's not a system or an architecture that we can leave out of the cosmic story, the story of nature. So basically, the book explains how the universe's most fundamental elements are organizing themselves into higher level systems, and that these systems become conscious and aware and are always learning. And basically, that life is a mechanism of further self-organization in the universe. So when life emerges and spreads, it's basically the system as a universe organizing itself into functional forms that can experience the system and that can create new things that don't exist in the system. So the idea is that life is cosmically significant, that consciousness has a causal role in reality, but also that life is not seen as dominating the universe, are going to dominate the universe in this story, but that life is part of the universe, a part of the manifestation of natural laws and evolutionary dynamics that emerge from those laws, and that conscious agents are basically the universe itself waking up, and they're the sort of the vessel or vehicle that allows the universe to experience itself.
Right. Yeah, I think there's a huge amount of overlap in our kind of worldviews, and then, as you said, also interesting places to explore different interpretations. And we both definitely have this alignment with naturalism, with non-reductionism. You know, you've done an amazing job in the book of laying out the technical evidence for these claims around, you know, this way of interpreting our circumstance scientifically, where life isn't a fluke, right? We're not these lonely little things that are an accident on the periphery of existence, where life seemed to spring up as soon as it was possible, really, on the Earth, and it really fits into our understanding of energy flows, right, in existence. So it might be worth just touching on that and the kind of integrated evolutionary synthesis, just the idea that the way that forms come into existence is not something that just happens with species, right? When Darwin hit on that idea, I mean, I remember when I learned that in school, even then it stirred something in me where I felt like this was the most insightful thing I'd ever heard. And I've never heard anything more insightful since. And so I even then I kind of got the feel that this is a statistical phenomenon that doesn't just apply to, you know, to species that have genes. And it's so prevalent, actually. You hear scientists, whenever people try to use these statistical principles of natural selection beyond species, they'll say, oh, but they don't have genes, or it doesn't have mutations, and kind of missing the fact that it's a powerful statistical phenomenon rather than something that's just narrowly, you know, against this tendency towards reductionism of like, it has to be about the genes. It can't be about the evolving systems. And so I think we both share this systems perspective of seeing emergence, you know, systemic holistic structures as real things, not things to be explained away into the reductionist kind of micro states. So yeah, it might be worth just unpacking a bit about why evolution is the way to kind of understand this evolving of reality.
Yeah, okay, because I do think, yeah, it's one of the key concepts. Um, and not just evolution, but evolution as learning. That evolution is a learning
Right.
process where systems that evolve and adapt are actually accumulating knowledge about the world around them, which is kind of obvious to us when I say it, but it wasn't really framed in those terms. It's like information was left out of that story. Um, so because, you know, I've seen people, for example, there have been like reviews on Amazon where someone's mentioned like, gave me a new perspective on evolution because I never thought about it in terms of information. And I was like, you know, and it made sense. But I mean, since I've been thinking about evolution in those terms for the last 10 years, but I mean, I didn't for 20 years. So I definitely, you know, when you learn evolution, you hear about, you know, genetic mutation and natural selection acting on it, survival of the fittest, but there's not emphasis that is building up information in genomes, and that information is predictive of the environment. Like, you don't hear the word predictive. You typically didn't hear the word information. So yeah, that we need to understand it in those terms, but we also need to understand it in terms of thermodynamics. And thermodynamics gives us not just a language that discusses its relationship to energy in the universe, and energy is needed for systems to do work, but thermodynamics also gave us this statistical language that you mentioned. That's super important too. And when you understand that, you see that thermodynamics and information theory and evolutionary theory and biology um, have these common mechanisms and this common language, and you need to understand all of those things together. And that's why I call it the integrated evolutionary synthesis in the book, because when Darwin's theory emerged, thermodynamics was really popular and that was emerging. And there was the second law of thermodynamics, which said systems tend towards disorder. And then there was biological evolution through natural selection, which showed how, you know, systems become more complex. And there was this seeming there seemed to be this paradox in that why if there's a second law, why do you get a tendency towards complexity? Everything should be going towards disorder. And you know for in the 20th century, people got really annoyed by people using that apparent contradiction to, for example, advance creationist theories, stuff like that. And they basically yeah, they made a big point to say that those things don't contradict each other. But what I'm saying is stronger. It's not that those evolution and thermodynamics don't contradict each other. It's that you actually need both of them to tell the story of evolution. And the need to survive, we always hear about survival of the fittest in biology. We need to understand that in terms of, how a physicist understands staying alive is staying organized. And from a thermodynamic perspective, that requires that a system constantly extract energy from the environment. Otherwise, it will fall apart. So if an organism doesn't eat food and doesn't drink water, which it needs to metabolize the food or breathe air, if it's not metabolizing energy, it'll die. And you'll see the second law's tendency towards disorder to kick in. And you see organisms decay and all of their atoms, dissolve. So the biology is really a fight against this tendency to fall apart. And the evolutionary process, the process of adaptation, is a process where genomes and brains acquire information through trying out different things, through trial and error, variation and selection. So you can see genetic mutation as the system trying out, as biology trying out different things, different experiments with different organisms. So you can see the whole biosphere as sort of doing scientific tests, and that organisms are embodied theories or embodied models about how to survive, how to stay far from thermodynamic equilibrium, far from this state of maximum disorder. And so then you see the biological evolution process as an information accumulation process or a knowledge accumulation process. And so then there's this, not just this unification between thermodynamics and biology, but there's also a unification with epistemology, because then it becomes this sort of theory of knowledge, and that evolution is accumulating knowledge. And so that basically Karl Popper, the philosopher who did a lot of work in the philosophy of science, was basically responsible for creating him and Donald Campbell, this sort of paradigm called evolutionary epistemology. And it basically said that evolution was a learning process. But it also said this, and this is what the book focuses on: evolution. So it's not being narrowly defined as you said. It's not just about genetic mutation and natural selection acting on that. All systems that can explore the space of possible configurations in some way, that can vary their form, can evolve if there's some selection pressure that filters out, the forms that are less stable. So one thing the book tries to do is redefine evolution, this survival of the fittest as survival of the stable. So it's like the stable structures that stick around. And once you have that principle, then you can easily see why evolution seems to have this appearance of leading towards increased complexity, and that would basically underlie the progress that we see with human civilization over the long term. So when you understand that the biosphere is just accumulating knowledge, because every little agent in it, and not just the individual agents, but at the level of those agents forming groups, the groups are being selected too. So there's all of these evolutionary mechanisms that are optimizing those systems, and that those optimization processes are learning processes that accumulate knowledge. So then you see why there is this tendency towards higher complexity. And it's not an illusion. It's actually real. It's not this perfect line that would imply something maybe mystical driving it. It's a process of learning through trial and error, much like an AI. So this starts to lead to the picture of the universe as something like a self-organizing system, or a complex adaptive system, or even like an organism or a brain or a neural network. They're all information processing systems. And the reason I throw in neural network is because there have been some recent papers that have argued that the universe is a learning machine or a neural network. And I'm currently writing an article for Big Think on that, and it should be out in the next few weeks. But those papers are really interesting. One is by a physicist called Vitaly Van Churn, a highly respected theoretical physicist. The other paper, called The Autodidactic Universe, is by Lee Smolin and Jaron Lanier. So pretty big names, and some other people at Microsoft. Um, so there seems to be a new paradigm that's emerging that's basically changing our view of the universe from something that was random and arbitrary towards a system that has this non-arbitrary evolutionary trajectory, such that the universe grows more complex and such that information accumulates in the universe, and the universe organizes itself in a way such that these conscious agents arise. Not only that, but the networks of conscious agents seem to get increasingly robust as they learn, such that it's really, really hard to kill life, which makes this sort of tendency towards higher complexity, which drives the spread of life, inevitable, because the system just gets more and more robust. It's just this learning process, just like training an AI, like a really terrible chess playing program and letting it play, giving it tons of challenges and data by playing other people, other programs, or other humans. That if the chess playing program is storing those patterns, it's going to get better and better over time until it's unbeatable. And so I think the biosphere is something like that, and that the whole system has this architecture, which is very brain like. If you look at the structure of the cosmos, it's called the cosmic web. It's Sabine Hossenfelder wrote an article about this for Time, about the similarities between the connectome in the brain and the cosmic web. And she asked, could the universe be thinking? And she said it's consistent with what we know so far, but we don't really have evidence to either way. And it was pretty amazing that she said that, because she's known for being a skeptic. I don't think the universe is thinking at the moment, but I think what that cosmic web is, we're seeing the architecture, the scaffolding for the emerging cosmic brain, that basically is created by the spread of life, the spread of all of these agents that create this integrated information network. Because as life spreads, it basically takes the inanimate matter in the world and it incorporates that into its computational substrate. So the network that's intelligent, that emerges on a planet like Earth, slowly but more and more quickly over time starts to spread and subsume the universe, the very same way that life started out as a single cell on the planet Earth and then spread and now just completely covers the planet. So that's really everything in the book, and that's a lot of the technical details too. I didn't talk about consciousness or free will. That's in the last part, or why the universe has this structure and in what I called a non-arbitrary evolutionary trajectory, a sort of developmental trajectory that you would see with an organism. But yeah, that's the gist of it.
Yeah, that was a great overview. Andy, I think we'll probably swim in and out of the big claims and then the technical detail, because you're right that that's like I think a good way to present these ideas. So to recap some of the core ideas, you mentioned information, and so when we're talking about information here, we're talking about correlations, really, right? Like something has information on something else if there's a relationship between the two. So if I ask you where something is and you give me a random string of gibberish that has no information about where the item is, but if it actually correlates in some way, then information has been transmitted. So the structure of the organism has information about its niche, right? Like in the book you use, I think, the example of a key as a model of the lock that it fits. And so a giraffe's neck is a model of the height of the trees, given that it's a leaf-eating thing. And so in this way...
Yeah, and it's spots too, like,
right.
it's camouflage, for example, is knowledge of the environment.
Yeah, and like the shape of the way a fish swims contains information about the dynamics of water, and so everything, all forms are kind of these informational dynamics playing, right? So you've got adaptive information, information that allows systems to be stable, and this appreciation that the cliche that knowledge is power is really true. That like in order to exist, you need to be getting information about the world around you in order to have agency, in order to act in the world. You can't have no information. If you have no information about the world around you, you're going to get subject to second law of thermodynamics. You're going to decay. If you're going to maintain order, you need to have some kind of knowledge. And then,
Exactly.
you're saying that so evolution is this knowledge, this kind of knowledge creation process, this learning process, and I completely agree. But you're saying that it's open ended, right? That it's kind of the usual interpretation of second law is that entropy is going to win out, everything's going to
Yeah.
result in heat death of the universe, and you're saying if you actually are more precise about different kinds of entropy, there's a way for the kind of the emergent order to keep going and without limit to keep that basically order will win out over disorder. Is that right?
Yes, and I thought that was going to be yeah, and that's great because I mean, yeah, you extracted like all those points. Those are the important ones. And I thought that was going to be like the hardest issue to convince people about because you have all these, the second law, you have all these just kind of ideology built up around it where it's not supposed to be challenged. Sir Arthur Eddington has a famous quote where he basically says that like you'll be embarrassed if you try to challenge the second law, like you better not try to. And yeah, there's so much interesting stuff to talk about there because like Lord Kelvin, Sir Arthur Eddington, they were responsible for popularizing the second law, especially Lord Kelvin. But both of them were very Christian, very religious. So it turns out that the second law in heat death actually has like a religious motivation. I don't think anyone would know there's like a Christian motivation behind the heat death thing. And we could talk about that some, but there's a dissertation online that's about that. But I also, do I bring that up? I don't think I mentioned this article, but I recently wrote an article for a website, Noema, a great website that publishes stuff about this. That it kind of reminds me of the site Aeon. But yeah, they do long form essays, and this article is called "Life Need Not Ever End." And it's a 4,000 word article, so it has all of the details that you would want, and more. And it argues it explains the different types of entropy and the kind of you know misunderstandings of the second law of thermodynamics that we have that led people to that conclusion that life is transient in the universe. But what I argue, and even when this article, even though the book had the same idea pretty much, but not as in detail, and no one seemed to have any issue with it. And people like skeptics like Michael Shermer and physicists like Adrian Bijan, people who are really familiar with like thermodynamics seem to be fine with it. So I was like, okay, but we'll see what happens when this article comes out because, when stuff's on social media, then people attack stuff. Just you can expect it. But I was surprised that David Deutsch shared it. Not really surprised that he shared it because he was one of the main people that argue for this, who I've mentioned in the article. But Sabine Hossenfelder commented saying something like says something similar in her book. She was like, I have a chapter on this in my new book. And then Robin Hanson said, yeah, it's possible that life can go on forever. It depends on whether there's an upper bound to entropy. So a lot of big name, like people were supportive of it. And I didn't really see many people being critical of it at all. So because the article, it doesn't say that life is going to go on forever. It says it's not certain that life has to end. So it's a kind of a weaker claim than it won't end. It doesn't have to end. But basically, yeah, if the universe, it's kind of complicated, but there's as long as there's some energy, free energy, usable energy that hasn't been used up and converted into entropy, um, then life and complexity can continue to grow. And there seems to be no limits to the amount of energy, it gets really complicated. We can talk about cosmic inflation theory, but with cosmic inflation theory, I mean that anybody that's the reigning theory in cosmology, and in that model, you can get unlimited energy in reality, and actually, that's what's happening. According to cosmic inflation, new universes will be created forever, and new universes with life will be created forever. So life will go on forever. Alan Guth says that very clearly. But the old idea was that life would die out in each pocket universe. But even in that model, life and universe creation continues infinitely, because you get positive energy and negative energy, and you can create as much positive energy as you want, as long as that's balanced out by, so positive energy would be like matter, anything that we can use to convert into energy to do work, and then the gravitational force associated with that matter, which basically counteracts, um, or balances it, but it doesn't limit the amount of extractable energy. It's just balanced. So physicists can say, oh well, we have new energy created, but there's positive energy and there's negative energy created at the same time. So the total energy of the universe is zero. That's not changing. So they say conservation of energy still holds. It's not being violated, but in a way it is, because you get all of this energy for free as long as there's negative. So to some people, they might be like, what are you talking about? This guy lost me. But no, look up positive and negative energy. You can see people like Sean Carroll talking about it. Energy is not conserved. So yeah, if you really look into this story and the work of this guy, David Laser, who's kind of the first person to say it, but other people have made this point. But if the universe is expanding and it's being driven by dark energy, actually dark energy, you can go on Sean Carroll's blog, type in energy is not conserved, and he talks about this recent article that he called interesting, that basically says with cosmic inflation, new dark energy is being created all the time. So as space expands, if dark energy also is turns out to be extractable to do work, that's another unlimited source of energy. And some in that article, I link a paper by some astronomers who have argued that dark energy, that we can harness dark energy to do work. But the other idea is that just if you have an open universe that's expanding, that the maximum possible entropy arises faster than the actual entropy. So there's this what's called an entropy gap, which would basically mean that there's free energy forever. So it's an idea that people aren't really used to, but energy hasn't really been conserved. That laws, since relativity, but then there's newer things to basically suggest that the energy supply might not be limited in the way we thought it was before, which would allow knowledge creation to continue forever, which David Deutsch says all the time in all of his books, and people don't seem to have much of a problem with that either, that there are no fundamental limitations to knowledge creation. So the second law of thermodynamics, depending on which version you talk about, because that gets a bit tricky too, but really should only be applied to closed systems inside the universe, not the universe as a whole. There's way too many things about the universe we don't know. Julian Barber has said the same thing, just that we don't know enough, and that it seems like the story of the universe is the story of increasing complexity. He doesn't really talk about the future of life, but he just says the universe isn't becoming more disordered and the universe is becoming more complex, and the second law should have never been applied to the universe as a whole. And he's a highly respected theoretical physicist. That book came out a couple of years ago and got great reviews and people like Sean Carroll. So everything we thought we knew about the universe, I was going to say, is wrong. It's not certain, and it's probably wrong. And I do think this new story will be in a few years, will be the kind of accepted paradigm, that the universe is a self-organizing system, and that explains the increase in complexity that couldn't be explained by the old paradigm, and that complexity isn't transient, that the universe seems to be this sort of computational system that's organizing into a fully integrated computational state. And that's the role of life spreading, is it's basically the universe learning. And like I said, life is kind of like an AI. It's kind of funny because maybe it's not so surprising, because AI was modeled after life. I mean, it's called artificial intelligence, but it seems like life is also we can learn from AI. We can learn about AI from looking at biology, but we can also learn about biology from understanding AI.
Right. Yeah, and I'm glad you made the differentiation between the kind of the stronger claim that order will win out and complexification will continue infinitely, versus the weaker claim that it's not certain that we'll end up with heat death and just complete disorder. Because I feel a lot more comfortable with the weaker claim, the like of being open to
It's
different
possible,
possibilities.
but not inevitable.
Yeah, so I think
Yeah.
a big step for me seems to be whether or not life gets off planet. So you were saying life is a very robust phenomenon, and that's true
Mhm.
on planet Earth, but it seems possible to me that there is a very hard barrier to be technologically sophisticated enough that you don't become fragile and destroy yourself as a civilization, but instead can get off planet. And I think if once we get off planet, or if we get off planet and we set up, terraform other planets, then you've got a very good case that humanity will exist as long as our universe exists, or as long as there are ways to extract energy. It'd be hard to kind of stamp it out everywhere. And in that scenario, I guess because you're saying science, human kind of ingenuity and technological innovation is all part of this same process. It's part of the same evolution, and science are all part of the same continuous thing. So are we imagining a future where, say, the easy thing to imagine is you've got humans spread throughout the universe, they're using up all the energy, and then gradually all the suns go dark, and basically they're sucking up all the energy and turning it to entropy, and then you've got the heat death of the universe. But are you saying it would have to be some kind of technological innovation that would harness new forms of energy that these civilizations could go on, so that forever then they're creating positive energy or whatever tricks there are from these kinds of aspects of physics, but they're not just sucking energy as a kind of ever diminishing resource?
Suns are great. They're big batteries in the sky, and that's what gets life going. And that's what we're going to exploit for more energy. That's going to be the obvious thing. But all matter can be converted into energy. That's what EMC squared showed. And so, that's why we split atoms to get nuclear energy. And we are probably about to make nuclear fusion efficient, like in the next decade or two. There have been some interesting breakthroughs. So what I'm saying is that matter and energy are created continually in an expanding universe, such that even when the stars, I mean, we'll be able to, nuclear fusion is the process powering stars. So as long as we have some form of matter and energy, um, it's just basically like having more stars around. Uh, and so just to mention a couple things, because you're right to be skeptical about that, and people should be. Um, the psychologist Greg Henriquez said something to me similarly. Um, and so, as scientists, we want more than one sample, right? We want a larger sample size before we say, oh, that's true. Like, let's find another biosphere and see if it's spawned intelligent life. Of course, it would need the same conditions, but it would also need to have the time scale that we've had on Earth. So it would need that amount of time at least, and it could be slower on that planet for some other reason. But you could imagine us being here. This is kind of a thought experiment, so it's not completely realistic. So you can imagine we're capable of time travel, or somehow we were here observing. Maybe we came from outside of the universe, but you and I are analyzing biology, and we're trying to make predictions about where the biosphere is going. And so you're like, yeah, we're here where we are. We have rock, we're leaving. You didn't say this, but I'm kind of like putting words in your mouth, but here we are, and we have rockets, and we have technology that can maybe, like, we can maybe make AIs, and we can maybe slow aging, or maybe even like stop aging with like nanotechnologies. There are all these possibilities, but you're like, that it would still be great to see that next stage happen, so you would know that we passed these sort of great filter challenges. But imagine that you and I are here and we're making bets about where the biosphere is going to go, and whether, higher intelligence is going to evolve. And there's only single celled organisms. And we go, okay, we don't know what's going to happen in the future. Let's take this Bayesian approach. Let's make some theories about what's going to happen next. And based off what we know, and see what happens. And we would, when we see single celled life, it would seem very improbable when life emerges. We would probably be betting on whether it's going to spread, across the continent, across the planet. But, spreading throughout the universe to where it subsumes the whole universe, that would seem crazy. But we might, make some bets about whether it's going to do these things. And it would seem pretty improbable. But then we would see that multicellular life emerges, and then we'd be like, holy crap, like this is like this whole new level, and now it's spreading, and then like these plants are growing, and like now the surface of the earth, the solid part, is largely green. Like, that's crazy. And then, you know, we get intelligent things that start to build like industry, and it's like, oh, we have the Great Wall of China. You can see it from space. Like, it's actually changing like the macro structure of the planet. And like, so you have a series of evolutionary transitions or metasystem transitions where you have what used to be individual agents come together to make larger, more complex agents. And a lot of those steps were thought to be improbable. And some of them are still thought to be, and some of them we're seeing that they occurred, many times and stuff. But what I'm arguing is that we do only have one sample size, right? One sample, we can only see our planet. But like, just with that one sample, all of these transitions have happened. Not only that, it happened in a timely manner such that life is getting off the planet. When 100 years ago, it didn't even seem like, people didn't even know if it was possible to fly. Like, planes were invented 200 years ago. And like, there was a New York Times article that predicted like 20 years before the plane was made that planes would take 10 million years. It's like, I'm sure that person got fired. They said, yeah, I'm pretty sure the article, it said 1 million or 10 million, but, and then it was like a year later. But, so yeah, that guy didn't make a great prediction. But so what I'm arguing is that there's all these converging lines of evidence. For example, Paul Krugman, a famous Nobel Prize winning economist, said the internet was going to go the way of was going to be about as impactful as the fax machine. He didn't think it was here to stay. So what I'm arguing is that this theory that Teilhard de Chardin had, that the biosphere is going to a more complex, increasingly complex state, it has predictive power. And if we made that theory 1,000 years ago, or whenever, if we could travel back to before the Cambrian explosion or wherever, and we kept saying, okay, we could have this is an arbitrary system, and it's getting more complex, but it's the complexity, there's not a tendency towards greater and greater complexity in an open-ended way. It's just getting arbitrarily more complex, and it's more complex than it started off, but it's not going anywhere. That could be the case. But if we had that and we kept having different competing theories, and I kept saying, well, one day it's going to go into space, we go back to single cell times, it would just seem so unlikely. And then we would keep doing experiments, and we would see, okay, now we have multicellular life. Now we have this, and now it's getting off the planet. Whoa, now like Ray Kurzweil is coming up with theories about how life can spread through the universe. Like, oh, we see this as possible. Now we see that through quantum teleportation, for example, we can exchange information over longer distances faster than we thought. Like, we find out these new sort of exploits that if you read a pop article about the possibility of this 10 years ago, it would be like, we can't do this because we can't do that. And we're like finding out all these little things. So what I came, to believe over time was that the best theory is this theory that predicts that the universe is this self-organizing system. And it's not just becoming more complex at an arbitrary rate either. Life is getting off the planet in the time that it needs to escape the death of the sun. Because if life doesn't do that before the sun dies, then life really has no chance of getting anywhere. So we're one sample. And if there's just going towards arbitrary complexity, like it's not really getting more and more complex in this manner that I'm saying, that is actually like meeting the timeline that we need to, that would be extremely improbable that this one sample that we happen to be in, where we seem to have this trajectory where we just keep going to the next level and next level. And to me, I think that shows, and you can do thought experiments where I'm arguing, if you understand this trajectory, then you could imagine rewinding the tape, and that it just basically, there are these attractors that lead to this trajectory. And you see that with Simon Conway Morris's work on convergent evolution. But what I'm saying is, so for example, we're not getting off the planet because this happens to be the time, like random. It's not random that we're doing it now. What I'm saying is intelligence is evolving at the scale, at a rate that's determined by the challenges that it's being presented with from the environment. And any intelligent species that emerges will learn about the laws of nature because they will have to model the world in more detail. So they'll start discovering math and biology, and they'll learn about the second law of thermodynamics, and they'll learn that they have to get off the planet at a certain time for life to continue. And so Elon Musk's decision to, really try to get life off the planet, it's not a conscious decision, really. It's if you had this theory and you went back 100 years ago, you could be like, well, when that technology emerges, there's going to be an effort to get life off the planet because that system will have this biologically programmed imperative to survive, and it will start doing things to do that. So, I don't want to stay on this point too long, but I will say one more thing, because I mean, for most people, it's the main point of skepticism, because I mean, the great filter theory was, the idea that advanced civilization will destroy themselves is kind of the explanation for the reigning explanation for the Fermi paradox, that we don't see that out there because that's what always happens. I'm saying that's not the case. And I don't think that happens at all. I think once it gets to this level, it's like so robust, and it learns in such a way that you can't stop it. The way I explain the AI just keeps learning patterns from playing humans. And once that AI becomes deep blue and beats Gary Kasparov, another human player is not going to come and randomly beat it. So like life just becomes so robust that the challenges, like if a meteor comes at us, it's not, the threat doesn't harm us. It actually does us a favor, because there's a statistical response by humanity where when there's a threat, a certain amount of people will predictably act in a way to stop that threat, such that there's a response, and then it motivates all of this learning, just like the pandemic motivated all of this like AI research. It changed the dynamics. We work from home now. It it just filtered out all of these inefficiencies that we were doing. So it was bad for the short term, but long term, it probably did a lot of good. And we see that World War II, for example. It's like, oh, people thought the world was going to end, but we got computers and we got information technology. And if you look at the trend of technological progress, it was actually sped up. So there's a principle in the book that I call Popper's principle, which says problems create progress. So there's this like paradox of my story, the story of in this cosmic narrative of increasing complexity and progress, that's challenged by all these threats. And what I'm saying, and it seems like it makes it unlikely. And the point in the book that I really tried to stress that I thought was novel, but I'm going to throw out a word which is very old. You'll see it's not completely novel, but novel in this new framing where you're talking about life versus entropy and order versus disorder, that there's actually this dialectical dynamic between like order and disorder. And so Popper's principle, problems create progress. It's actually the challenges, the threats that are pushing the system to adapt, and not just adapt, but in a timely fashion. So the sun burning out is a thermodynamic deadline for life to get off the planet. And so let's say, so Greg was like, you don't think that the Cuban Missile Crisis, Greg Enriquez, you don't think the Cuban, like the planet, like nuclear war could have broke out? You think it was inevitable that we avoided that? I'm like, absolutely not. Like nothing is completely unavoidable. And in the book, I talk about how reality isn't completely deterministic. There's this probabilistic or random or stochastic element where you do have some freedom, and you do have truly open futures where you have these counterfactuals, you have these possibilities. And but what I am saying is that if there was a nuclear war, a lot of people would have died, but not everybody, not highly likely, like statistically likely that it wouldn't be most people. And what would happen would be there would be a predictable statistical response. So what I'm really saying here is that there's a social statistical mechanics. There's a statistical response by humans, the way that you can look at the way physicists have looked at inanimate systems and try to understand statistical mechanics and the behavior, of systems in aggregate. So you see these emergent behaviors that we can actually understand human society in this way, and we can start to predict human society, even though it's not, even though nature's not completely deterministic, there's a lot of determinism. And actually, yeah, this is what I'm really focused on talking about, like in the next book. But that uh basically this trajectory is predictable. Oh yeah, so if there's the nuclear war, then there will be all of these extra controls put in place after that disaster that make it even harder for that to happen again. So each time there's a disaster, there's an expected response from humans that is statistical, and we're not even fully consciously in control. There's going to be, bad actors always, you can predict, and there's going to be people who try to stop those threats. And so through this process, it's just like this trial and error kind of learning, machine learning type process. That is where the inevitability comes from. And I think that's the new idea. And it's hard to wrap your head around at first, because it just sounds like you're saying that life is doing something mystical where it just defies all these threats. I'm saying, no, we have to start taking this kind of idea of life is sort of like an AI seriously, because what I'm saying is it's sort of like a system that's being trained, and that it's inevitable because the universe has this self-organizing sort of wiring diagram, this sort of trajectory that goes back to the fine-tuning of the constants, like the specific parameters that make this process inevitable. But yeah, it's a new, really different way to look at it, because it basically says that it's not this mystical teleological force that's driving progress. It's this process of continual failure, which motivates learning. So no civilization success is guaranteed, but overall, statistically, the ascent of life, the progress of life is guaranteed. And it's not necessarily saying on this planet, but it's saying that that's highly likely, and that the more as life evolves, it gets more and more likely. But let's just say there's some cosmic accident where an asteroid hit the planet that was like as big as Earth, and it just wiped out intelligent life. And let's just say it just keeps happening. Maybe there's one planet out there that has life where it's just an unlucky spot where it just keeps getting hit anytime an intelligent species emerges. This thermodynamic story would argue that that process of life emerging, it's not just inevitable that life emerges on thermodynamic grounds. What I'm arguing is that this process of metasystem transitions, where you get these increasing levels in this growing hierarchy, that's inevitable. So even if it stopped here on Earth, statistically, the self-organization of the universe through the spread of life would still happen.
Right.
And Vitaly Van Schoen, the guy who wrote the Neural Universe as a Neural Network paper that I mentioned, I spoke with him last week, and he thought that was the same. He was just like, statistically, it's going to happen inevitably at some point. The universe life's going to spread, and it's going to be a fully integrated sort of computational system. And that was really exciting to hear from someone like him. He's worked with Alan Guth and people, the founders of cosmic inflation theory, Andre Lind and stuff like that. So.
Right. Yeah, I think the counterposition to your position is, as you mentioned, the idea of these great filters, where if the claim is that the universe is undergoing classification, I mean, obviously we are part of the universe, but I feel like if it's the universe as a whole versus this is a local phenomenon that's playing out on particular planets, but it stays confined to those planets because there's some inability to kind of get off planet and make this a truly cosmic unfolding. That feels like a yeah, the sticking point of these two different perspectives. And I wonder what is your take on the Fermi paradox? Why are we just very early in the unfolding of the universe? Why do you think we don't
I
already
think so.
see? Okay,
I think so. Here's something to think about. Um, let's say you have a universe that's plentiful with life. It emerges everywhere. All of the early civilizations are going to experience the Fermi paradox, predictably.
right.
Every first every first civilization is going to look out and be like, where's everybody else? So any civilization that's early on in this process is going to have the Fermi paradox. Doesn't mean that life's not going to spread. It means it hasn't happened yet. So I do think that um, these processes take time. So before life, you needed stars. I think you even need like second generation stars or something. So you needed like planets and stars to emerge, which took billions of years. So life couldn't have emerged like 10 billion years ago. And Joe Rogan made this point when we talked. He was like, but it could have emerged like 10 million years ago. And I conceded, I said, yeah, maybe there's planets and stars, but maybe not. We don't know what sort of planetary conditions. So if life emerged on Earth really quickly, as you said, as Carl Sagan and Stephen Hawking have pointed out, which seems like the emergence, a lot of people now are sold that that part's inevitable, even though that was the hardest part to convince people of a long time ago. That was the accident, the great accident was that life emerged. So it's funny that now a lot of people are willing to go there. So I'm saying soon, it's just going to take some time to get people for the whole process to be convincing as inevitable because there are all these mysteries. But basically all of these things had to happen on the planet. Like, first of all, simple celled prokaryotic life had to spread and like actually change the atmosphere to be filled with oxygen to allow for aerobic life, more complex life. So because life arose so quickly, it makes me think that all of these processes kind of have a time scale that is needed for them, for that part to happen. And that if it happened here in a sort of inevitable way, that it's probably happening elsewhere in the same way for thermodynamic reasons that I explained in the first part of the book. But also, it took those conditions, those same processes had to happen. So it's probably life is probably emerging on a similar time scale. So I don't think it's that surprising that we don't see others. I also think not only are we some of the first, I think that it's not happening on every planet. You have to have those right conditions. And, you can argue about whether it's rare or not. It depends on how you define rare. But what I'm saying is it's not as rare as thought before, that it could have only happened once in the universe because we didn't understand these thermodynamic principles of self-organization. It seemed highly unlikely to get a cell because they thought it was just a random collision, but it happens over this slow, gradual process. And so life might be really far away, but it might be out there. It might be on billions of planets, but maybe those planets are all pretty far from each other because statistically to get these conditions, it's not going to be everywhere. But that it's kind of like a forest. Um, even if lightning strikes one tree, and you could theorize, oh, well, people might get scared if they don't know anything about lightning, and lightning strikes the tree that they get apples from. They might go, well, what if lightning strikes every tree? And then they don't have any laws against why lightning couldn't strike. And they go, well, it's possible. And I guess it'll happen if we wait long enough. But no, we know that lightning doesn't occur that often. So you can't stop the forest. So I believe that the universe is in the future, it's going to, the force is life spreading, and that you can't stop that, even if it gets stopped in certain places, or slowed down to the point where it can't get off the sun, in the time needed. But, yeah, maybe I meandered a little bit. Did I
No,
answer
that's
your question?
great. Yeah, yeah. There's also the idea that to be an emerging civilization like we are, that can only happen before the universe is saturated with galactic civilizations. So if say we do spread out and every part of the universe is overtaken by competing kind of galactic civilizations, then a new one can't emerge in places that are already colonized. It would be like Homo sapiens evolving in the middle of Manhattan or something. There's already, all the energy is already being used there. Like it's not, it's like to use the forest analogy, if you're a sapling, you know, once all the trees grow really huge and they block out all the sunlight, new saplings can't grow. There's only the big established trees can survive. And so it's like, if you're a sapling, by definition, you don't exist in a big, thick forest where all the light is taken by the mature trees. So you can only really find yourself, it's a way of thinking about the Fermi paradox, where it's like you can only find yourself here at the stage we're at before there are galactic civilizations. If they existed, we wouldn't be able to emerge on this planet because it would be colonized by another species. So that's just to support what you're saying.
Yeah. That's interesting. So, when you start thinking about it, there's lots of like constraints that make it similar to sort of the anthropic principle, where you're like, we have to be seeing things this way because that's what you would expect to see. But I was going to push back because I thought you were making a different point. Well, you did make a different point inside that about once advanced civilizations spread, they might not be open to accepting new civilizations.
If the assumption is that it's an expansionist, competitive kind of, dynamic of trying to dominate, to control energy resources. So that's the assumption working with on that.
Yeah. So I'm not certain about that. And I'm excited to say that because I think if I could convince you, it would be something you would be happy to accept, given the implications of what I'm about to say. But so I think it's like that early on with organisms competing. But I think basically organisms compete until they realize that cooperating makes their task easier, their thermodynamic task of extracting energy, whatever they need to do to survive. It's easier when you work together with people because you get this effect that's been called synergy, which is very real and understood mathematically. And it's why colonies form. It's why ant colonies emerge through evolution. It's why human societies emerge. It makes life easier to work together. But we don't know that, and we compete. But when we're competing, we almost by accident find, some sort of dynamic or relationship between someone else cooperating, and then we become a unit. And then natural selection starts to act on that larger unit. You start to act as a whole. So one big thing about the book that I really focus on later and at the end of part 2 is this, point of, once we got life emerging, inevitably you have this hierarchical evolution process where these agents come together to make these larger agents, kind of like Voltron assembling into a larger Voltron. That's what I'm saying the story of cosmic evolution is. And we see it on the biosphere. It begins with living agents forming this biosphere that seems to have a global brain formed by humans. And then the whole system is the body. It's Gaia is this self-regulating system with a nervous system made by humans and their information technology. And sorry, I lost my train of thought.
I know I'm actually excited to come in there because I was going to say that in that analogy,
I remember
the self-regulating system of Gaia with us as the nervous system, it feels like the prediction there would be that we're going to successfully do something about climate change with some solution that would bring the bounds back, bring things back into regulation. If it's truly, if we're a helpful part of Gaia's self-regulation.
Absolutely. Right. That's what the book, very much. So I want to be clear about that point. Some people think we're this cancer for the planet. And what I'm saying is that's absolutely not true. We start off being a cancer, but then we learn we're part of the system. And then we start to understand that we have to take care of the system or it's going to hurt us. And I'm saying that's a predictable part of species becoming more intelligent. And if you have other biospheres of intelligent species, it's going to have the same trajectory. You need energy to expand. You find this new energy source, and then you realize it creates all these externalities. And then you go, oh, shit, like we're doing right now with, fossil fuels. So we're like, okay, we need a new form. And then we try to find solar power and nuclear fusion. And this is just part of this problem scrape process. So it's just what happens. But part of that process, as intelligence increases, you become more aware of the network that you're a part of. And you don't see that with less intelligent species, and you don't see that with trees and saplings. So, what I'm saying is, any intelligent species will have an understanding of the world where they understand this thermodynamic narrative and that they have to survive, and that cooperating with other computational systems is beneficial. Um, but it doesn't seem beneficial if you have one advanced civilization and one civilization is not as smart. Um, but what I'm saying is, okay, so this was one thing I didn't mention about the Fermi paradox answer, which I'll throw in right now because it's related. Um, so one reason, I don't. I think this is more speculative, but I think another reason that we haven't been contacted is I think an advanced civilization wouldn't contact a civilization that's intelligent because they don't want to disturb this trajectory. I would imagine that if we found out there was another intelligence out there, all of our efforts to like do everything ourselves and get off the planet ourselves would probably kind of stop, and we would put all of our attention on like finding out what that species is, or probably like trying to put it all into defense because we're worried about being attacked or something. I just think that any intelligent species, including ourselves, once we reach a certain level of intelligence where we can contact other intelligences, I think it might make sense that that species would not want to disturb the evolutionary trajectory because, and like I said, this is speculative, but I believe that biospheres are learning about the universe, and because we're all uniquely positioned in the universe, we might figure out certain things. Like you'd imagine we figured out relativity and quantum mechanics at different points in time and all of these things, and I think those are being figured out on those in those other areas by intelligent species. Like eventually, because we're just mapping the world and we discover the structure, the causal structure of the world. But that basically, if we met another intelligent species and we were at the point where we could travel through space, that it would be beneficial to merge and share knowledge of the universe. And I also think another thing that comes with higher intelligence is a greater theory of mind that you don't have of trees, that you don't have of lower organisms that just try to kill each other. As you get more intelligent, you become aware of other agents like you, and you start to value conscious agents more, and you start to understand suffering, and you start to have this sort of golden rule, like you don't want to treat other agents like that. So I do think there could be an element of a competition, like competitive element to this at all. But I also think that any civilization that has understood the universe at the level needed to achieve that level of technology would come to this same paradigm and philosophy of this self-organizing universe, and that it's these conscious agents spreading. And I also believe that life, for thermodynamic arguments that David Wolpert at Santa Fe Institute has made based on like this thing called the Landauer limit, that life is doing sort of optimal information processing from a thermodynamic perspective. And I also believe this is why I don't think we're going to get AGI that destroys humans or replaces humans. I believe AGI and AI is going to get super smart and like basically allow us to solve the existential challenges that we would not be able to solve otherwise. But I think human intelligence is going to have advantages over AI always, and that there's going to be emerging, but we're not going to be replaced. It's just going to be used to upgrade us. And um, and so I believe that there will be competition, but that there will be lots of mergers because there will be sharing of knowledge. There will be empathy for other conscious agents. And that basically that's the story of evolution. You get these societies that arise, they compete, and then they converge. And I mean, it's like I said, speculative. Maybe it's some optimistic thinking, but I believe that I think this for rational reasons, but that as species get more intelligent, they naturally get more compassionate as well.
Yeah, so that's really interesting. I think this is a good area for fruitful kind of discussion of disagreements, because my intuition, so as you're totally right, this is a speculative area, and my intuitions I think differ. And so whereas as you said, you have this optimism that or maybe maybe it isn't optimism and is grounded in rational reasons, as you say, but this belief that wisdom will go along with and compassion will go along with intelligence, or to me, what I see is that it's fearful, self-concerned, egoic, like psychology, that's what leads to a desire for control, and that makes sense in terms of survival, and that's what our desire for agency is about. And so our increase in technology and our ability to control the world is born out of the opposite form of psychology that would actually lead us into connection, compassion, mutual understanding. And I completely agree that mutual aid and symbiosis is equally fundamental as competition in evolution. Just look at flowers and insects. It's absolutely, it doesn't have to just be competition. But so, yeah, I feel.
But all
like
those things
the
are
wisdom
real,
part.
and they are keeping us back. Those factors are keeping us. That psychology is keeping us from achieving those great things. But what I'm saying is that it's a predictable trajectory that we evolve out of this, and that
Well, so
happens elsewhere.
the other thing
And
is
also the theory of mind thing is important because when we're talking about this, it's existential, but I mean, theory of mind is something very real where you have humans, more intelligent organisms. Part of becoming more intelligent is reading the minds of others. And when you model others in your head, then suddenly that's basically your way of dehumanizing them. So, yeah, maybe you could talk a little bit more about that, about why this argument against there being a correlation between caring about, trying to decrease the suffering of other conscious agents being correlated with higher intelligence.
Yeah, I mean, I'm definitely not against that idea that theory of mind seems to go along with increased cognitive capacities. I think both factors are at play, and what I perceive in the world at the moment is that the fear based kind of dynamics of control are are very large, basically, and are causing pathological dynamics that are not good for our flourishing, causing us to not collaborate effectively and compassionately and reduce suffering as much as we might. I'm a big advocate for psychedelic medicine. I'm hoping that that could be a way that people can actually heal the fear-based stuff in their embodied experience that allows them to come into more compassion. And I think that could have positive effects on society. And the balance we're talking about of kind of pushing people towards more compassion. So it is a possibility. But on the kind of optimism note, I think another important thing is that you were saying about how when you face a challenge, you overcome it. It's problems create progress. But
Yes.
the use of the word "you" there, I feel like it's statistically, because this is a trial and error process. It's way more likely we're one of the errors. It's way more likely that we're going to hit a dead end, and that a civilization out there somewhere else is going to succeed. And so
This
the
is a
optimism
great.
falls apart there for me.
Okay, yeah. Okay. Yeah. This is a great opportunity to try to emphasize what I was saying earlier. And it's really abstract because I don't think I don't think I've ever successfully articulated this. So it's not the listener's fault. It's my fault because I've tried to articulate this for a bunch of people and I think it makes sense. But yeah, so I absolutely agree. There's all these problems, and that's what I don't want. I don't want people to think that I'm saying anything other than that because, people, this superficial version of this teleological narrative towards progress is like everything's going to be okay. That's not what I'm saying. I'm saying there's going to be constant hell in a way, and we're always going to be fighting that. And even when we get to this higher level of if life spreads, like I'm saying, is inevitable, and there's these different civilizations, there's going to be hell there too. And there's going to be competition, and there's going to be cycles of competition and merging, and then fractures and merging. But overall, if you look at the trend, there's going to be this trend towards coming together, towards to where you get larger and larger networks. And I'm also arguing that there is a moral arc such that the brutality of the way people die, maybe physically, or how we, what animals we kill and what we don't. All of that stuff is going to get better, but it's never going to be perfect. And this, it will not end suffering, I don't think, because you could imagine psychological suffering in AI human hybrids, and just the thought of, maybe someone getting sick, maybe people still get sick and die. And you're like, oh, to those people, they're so much smarter. And there's psychological suffering about people getting sick and dying, just the way that people like getting eaten or something, or murdered, um, is now. So I'm not saying it's ever going to be perfect, but I'm saying there seems to be this clear trajectory where things get better, and that intelligent things start to model other agents. They start to understand that those agents were evolved in different environments and found different solutions to different challenges in nature, which could be helpful in some way. It's basically like, and I think once you get to that level of intelligence, really, there's just like, there's no, oh, we're the superior intelligence. We see that intelligence is, there's no metric for intelligence, because what are we talking about here? What is the challenge? It's just continuing to survive, and that means unlocking all of these different challenges, like in the universe, like different sources of energy, but different ways of interacting, technology. You're going to need different types of thinking. So I think that's what we've seen through nature is this, cycles of competition and cooperation and merging, and that's just going to continue. And because of this trajectory that I mentioned, you actually get less suffering, less evil in the world. So it is like and that's really something interesting to me, that if this evolution trajectory does have this moral arc. Um, but so to explain what I was saying earlier, which is the most abstract thing, the thing that I haven't really articulated that well, but I mean, it's the whole problems, create progress thing. So you did get, what I'm saying, but this is the part that I'm trying to kind of create this like social statistical mechanics. I think there's a new field of psychology that's based on mass behavior, kind of stuff that Isaac Asimov was envisioning. And I've been talking to Howard Bloom about this. He feels very strong about, making a science of this as well. And some people kind of have. Peter Turchin has cryodynamics, where he says, you can kind of predict the future based on these evolutionary cycles and these kind of social cycles. Um, so you said, there are all these like, people that want to, people are using fear mongering and control, authoritarian regimes, misinformation, all these bad things happening. And I think the solutions are, like I'm really a advocate for psychedelic therapy as well. I think it's insane we're not using like those things that we can use, or ketamine for. I mean, people are killing themselves right now who, if they had access to ketamine or psychedelics, it would save their life. Like it's just insane that like things don't change once we learn the uses for stuff. But let's say Putin takes over the world or whatever. Let's say whatever bad, maybe you think it's Trump, or maybe you hate Biden, maybe you think it's Biden, whatever. Let's say the stuff that you're worried about gets way worse, and you would go, well, this is what I predicted. See, that teleological theory is wrong. The world's going to shit. We're probably gonna, get caught by the great filter, and then, but some life will succeed somewhere. So I'm kind of optimistic about that, and that's a nice story. That's better than the old, nihilistic story that life is fundamentally transient and maybe only here. Um, but the point I'm trying to make is, if the bad stuff happens that you picture, there's going to be crises, and there's going to be a statistical response where a certain amount of humans go, I don't like this. I'm not part of this. I'm not for this. Those people are going to go on the internet. They're going to look for people like us. They're going to see they're going to see this conversation. They're going to see your podcast. They're going to see something that's talking about a solution. And then that, because it's in demand, because it's needed to solve that problem, suddenly the things that we're talking about goes from, a few thousand people caring to a few million people caring. And then that becomes, so the things that are the solutions that are there get amplified in response to this bad thing happening. So I'm absolutely sure that you're right, but I'm also saying the fact that you're right and that all those bad things are going to happen is exactly the dynamic that creates the threat that will force the conditions that will create a statistical response that makes the solution response to that threat. And that is always happening. And that's why you see that if you look over the last 1,000 years, infant mortality has gone down, the amount of people dying by disease has gone down, poverty has gone down, education has gone up. Because at any point in history, at any critical point, every 100 years, probably every like 30 years, people would have made the same sort of bets, but here we are, and things are better than ever by most metrics. And Michael Shermer and Steven Pinker have made great arguments for this in full books. Better Angels of Our Nature, The Moral Arc, by Shermer, something like that. I think that's the title. So the thing that I need to stress that is new to people that I think is just something that doesn't feel fundamental because it just feels like there's so much contingency in this process is that I'm saying there's not this contingency. And if you could look at the universe from like a bird's eye view, if you were like an alien observer, but like outside the universe, so like a multiverse alien or something, or like a meta alien, like seeing the whole process play out, you would be like, yeah, they think that, that this process that it can go anywhere, but it's not. There's this continual accumulation of knowledge. So you see this progressive thing. But my point is, it won't ever fix itself. So the bad stuff will continue to happen and we will be screwed unless we do something, because we're part of the system. We're the agents actually driving that. So part of me thinks that this argument that I'm making is not supposed to convince everybody, because if I did, then everybody might go, oh, well, we don't have to do anything anymore. The process is going to handle itself. But the whole point is that the problems are the other essential ingredient of this dialectical dynamic. So the moment that we think that everything's going to be okay, we screw ourselves and everything falls apart. But I think there's this Taoistic, like this yin yang, this dialectical dynamic, and that's how it works. And because that works, if you really go meta, you go, oh, it's just life is like AI. It's just training. It's just feeding it data, and it's just growing and adapting to spread. And so if you don't accept that, then it all seems very contingent and like it could or could happen. I'm saying, yeah, it looks that way. And it makes sense why it looks that way, because like it's through these problems that we have to respond to. If we give up, like the process ends. But I don't even think we have control over whether we respond to it well. I think if like shit hits the fan, like if an asteroid is coming, which is the same as the stuff you're worried about, like authoritarianism, like spreading or, surveillance, whatever. It's just like an asteroid coming. And if an asteroid's coming, there's a lot of engineers and physicists working on stuff that are going to immediately change to figuring out how we can get rid of that. And so that's what I'm saying is happening. There's always going to be bad stuff. There's bad stuff right now, but like James has a statistical response to that where he's going to put as much effort into content that's saving the world as in proportion to the threat. And if the threat rises, your intensity is going to rise too. And so this is always happening, and you see this incremental build. And then if you look at it that way, then it almost becomes inevitable everywhere.
So I think the inevitability piece is interesting that, if you talk about the inevitable complexification of life on Earth, people will point to simple things, right, that haven't evolved, like sharks haven't evolved over a long time. But you're saying, and correctly saying, that if you look at the biosphere as a whole, the kind of leading edge of complexity, which might be us, might be a similar species, then as a whole, there's kind of inevitability to this increase in complexification, but only when you kind of look at the whole picture. And so as this applies to this sense of optimism about human civilization, I guess what I'm saying is, if you look at a distribution of 1 million planets with advanced life on it, that's doing this kind of trial and error process, perhaps it's the case, because this is all just naturalistic and unfolding with no kind of design behind it, perhaps it's the case, just speculating.
I don't know if that's the case either. I don't know if I would accept that assumption.
All right, we'll get to that, because I realize now what I've
because cosmological natural selection is a process that gives you a design equivalent to what a designer would have created, And so it's a naturalistic theory that suddenly says there is
Right.
design. Yeah.
Right. So, but so I'm excited to get there. But
And I tend to believe that actually. So
so the so imagine you have this distribution of like a million planets, and all the ones that have animals that are some part prey animal, like we are. We're a mix of kind of predator and prey animal, right? In our kind of natural niche, that we're just too fearful to cooperate, and our fearfulness ends up with us kind of nuking each other. And but all the civilizations where apex predators become kind of technologically advanced, they actually manage to get off planet. It just happens to be that this kind of fear thing that prey animals have is this like it just short circuits the process, and we self destruct. In that scenario where humanity doesn't, where we're not the ones who get retained in the algorithm,
Mhm.
is that do you? I guess I'm saying, do you identify with the phenomenon of adaptive information, and would you feel that it doesn't matter if planet Earth isn't the one that gets to colonize the galaxy, as long as complexification keeps going, you'll feel some sense of kind of like that's a win for us because that's what we are deep down.
Absolutely.
Right.
Absolutely. Because if you were not happy with that, that would be kind of arbitrary because then you could just be as not as happy that no one in your family is going to survive. Like, oh, they're just strangers on Earth. Like
Right.
there might have and then if your family gets to survive but not you, you might similarly be not happy. Like, oh, well, I didn't survive. It's not me. I'll be dead. Who cares? So I think life surviving, that's massive for me. But I think that means it's even deeper than that. I'm not like, oh, it's not satisfying just because I think we got lucky. I think there is a design. I literally, I think that's the way to describe it, that there is a design or a building plan, as Ray Gould, Harvard astronomer who recently passed away, described it. Paul Davies calls it a cosmic script. Um, Heinz Pagels called it a cosmic code. These are all highly respected scientists. So I think it does follow this trajectory that suggests that there's something meaningful and purposeful about the universe as a system and its trajectory. There's some sort of intention kind of laced into this whole trajectory. And
So
so,
would it be fair to say you're a kind of naturalistic deist in that you believe there's some kind of simulation creator of like a maybe not simulation, but that our universe is a created artifact by an intelligence that came before us?
yeah, let's get into that. But let me just say one final thing about what we were saying. So, if you imagine the universe is a gas, if you take that simple, so then it would seem that it would go towards a disorder, and that's what Boltzmann, who came up with that principle, was really doing. He was studying a gas in a chamber, and then he thought that the universe could be that way because it was also made of particles. But the gas, all of the particles in it are just uncorrelated, and in his model, they stay that way, and they don't even interact with forces. They just collide off each other. So you naturally get, if something's ordered, it goes to disorder. But the universe has all these other dynamics and forces where you get this self-organizing processes. So if you want to imagine the biosphere as a somewhat like random system, you can imagine this distribution, and you can imagine only certain parts of that distribution succeeding. And that would be like, oh, well, that makes sense if it's statistical. But what I'm saying is the biosphere itself is like a statistical learning system that's just always adapting. So when you're saying like we're too fearful, what I'm saying is the most intelligent species who's reached a level of self-awareness where we can tweak our models. We can go, I'm not happy with the way I'm behaving. I'm going to change my beliefs. I'm going to change the way I approach life. I'm going to change my habits. Then it's not like we're going to be gone. Some of us will be gone, but then the like, for example, genomes, people that get filtered out, their genomes are gone. But what I'm saying, there's plasticity that allows for the adaptation that's necessary, such that at this stage, um, there's no reason to think that we're not flexible enough to where we're just defined as like, this kind of predators. I don't know if you said we were apex predators, whatever, but the kind of fearful one. I think that's basically saying that fundamentally we can adapt in the way that I'm arguing that we can and that we will because we have to. Not all of us, again. So the filtering that you're saying would happen at the level of our civilization when we get filtered out, I think it's already happening at the individual level. And because evolution is always creating new organisms, new copies, that you do get this robust process that allows for this statistical learning that makes the process increasingly inevitable that it's going to succeed. And just I'll throw this sentence out because I like this point and I haven't made it, but I meant to make it before. Like, we're not like anybody who thinks we're a cancer on the biosphere. If there was a big asteroid coming towards the planet and it was threatening all of multicellular life, like human intelligence is the only thing that could stop that from annihilating the biosphere. And I think, I mean, and it's interesting. This is just a basic point you can make like a thought experiment, but I've seen a lot of people use that point, like Ray Kurzweil and this AI researcher, Alex Visner Gross at Harvard, who talks about the universe being more complex and there being this design, this kind of like fine tuning that gives rise not just to life, but increasing intelligence. Kurzweil and him both argue that. And they talk about, it seems like there's a designer, but they don't go farther than that. But so I think they'd be attracted to these other naturalistic kind of explanations for that. So yeah, we will go there. But yeah, they were saying that basically if an alien civilization is observing Earth and like from a distance, and they're seeing like an asteroid come to the Earth around the year like 2050, for example, they're going to see that asteroid explode. They're going to see something be ejected from the planet and then blow up that asteroid. That's a cosmic event that isn't happening anywhere else. If you don't have intelligence, you're not going to see what's called anti-accretion. You're not going to see something leave a planet and hit something else. So the point I'm making and that they were kind of alluding to is like that's the nature of intelligence, and that there's this trajectory where you have life like affecting like cosmic events, and you could actually like see that and kind of like, and that's also showing that life and information has causal power. Like a purely inanimate planet could never stop an asteroid. So I'm saying that's like part of the trajectory that life basically the biosphere evolves to kind of perpetuate its own existence, and that we should stop thinking of as humans as so important. Humans are important. We're the most complex species. But what I'm saying is that if we go to Mars and we terraform Mars to make Mars friendly for life, we'll start putting plants on Mars. We'll start putting all these different organisms because we need this self-regulating network. When we do that, it's not so much like we went to Mars. It's like the biosphere is a self-replicating entity that replicated itself. And then you have a different planet with different conditions. So there's variation in selection at that level. So I see life spreading as the biosphere, as a self-replicating entity at that new level spreading. So once you start to think about the biosphere as this statistical sort of learning algorithm, and it's learning, it's not just arbitrarily evolving, then you start to see how there's a naturalistic explanation that could support an argument that life here and wherever intelligent life arises, it becomes so robust that it's unstoppable.
I think,
but again, it's the most speculative thing in the whole book, and tons of people wouldn't agree. But
yeah, I think I love the biosphere replication analogy.
I just hope that the argument I'm making makes sense from a mechanism. Like you could at least see what I'm saying, and that it's not supernatural.
Yeah, you've done an amazing job you've definitely achieved that of laying out the case very well. And so that's what makes it fun to then go into these more speculative areas because it's got a solid foundation. I think on the speculative, especially the kind of instincts around what interpretations to put on this. So you mentioned the narrative that civilization in its current mode is like a cancer is a kind of common thought. And so in the kind of picture you're laying out, it would be as if a cancer destroyed its host. If this is in the assumption that we don't fix climate change and ecological destruction, and then the cancer manages to kind of then move on and consume another host and consume another host. And I've heard people say they feel like if we do become a galactic species, that will be the kind of a terrible tragedy because we'll come across other lives and we'll harm them and destroy other planets. And this very much taps into our intuitions around which side of human nature we tend to find more salient, the self-concerned, destructive, selfish side, or the benevolent, compassionate side. And humans have both of those aspects. And so in that, you've used the word progress a lot, and when one uses the word progress, I think that implies that this is a good process in some way.
Yeah, it is in my use of the term.
Progress.
Yeah, I'm arguing that it is. And I don't think it's a good analogy to be like, oh, we're like a virus. You could say, well, the virus is like life. The virus, we're not like the virus. You're reducing us to this thing with bad qualities, but it's doing this kind of replication thing that is what life does. So just because we share some similarities doesn't mean we also have to have the bad thing. You could try to look at viruses as having a good aspect. And I actually do think viruses play like a pruning role as far as like there's some role. Okay, let me put it this way. If viruses, and this may be kind of getting off topic, but if viruses disappeared tomorrow, I think human civilization would not survive. I think the whole biosphere would start to break down. I think it would be like the bees disappearing, like the pollinators disappearing. I think the viruses and everything that is doing something significant, having some sort of impact, is playing some sort of role in the stability and evolution of the biosphere as a whole. So, I've also seen people say that, this is kind of different, but a little bit similar. Like, we're not even like, as this conscious agents, we're really just vehicles for our genes, and our genes kind of are controlling us like they're a virus. Like we're being controlled by these low level replicators. I don't think that's right either. I think when consciousness emerges, that's the center control center, and genes basically that was just nature's first memory, one of the first memory systems, and that we shouldn't be reduced to genes. So yeah, going back to the story of intelligence spreading, and as you evolve, you have this greater theory of mind. I don't think that's the right depiction of us spreading and being sort of like a virus. I think what the better way to look at it is you have an inanimate, cold, sterile universe. And what is spreading is the capacity to have experience, to experience music, to experience love, to experience suffering. But that's what's spreading. And I do believe, because there are these principles where complex systems need variety. And that wasn't in traditional evolutionary theory. But when you understand that it's not just about agents, but that these agents come together to make larger wholes, they always, when they make this larger structure, and all adaptive systems are this, we're not individuals, we're communities of agents, we're communities of cells. Our brains are communities of neurons. And so when you understand that, then you stop placing so much emphasis on the individual, and you see how these different levels, different layers, and you have these complex adaptive systems that are nested. You need variety in the system. So we have 200 cell types because bone cells or red blood cells are really simple, fairly simple, and neurons are really complex. You need a division of labor. For life, you need carbon, hydrogen, oxygen, nitrogen. Carbon makes four bonds because it has more complicated properties than hydrogen. So you need a variety of parts and a lot of connections between those parts to generate complexity. So if the world is generating increasing, complexity and increasing levels of organization, you mentioned the alligator not evolving earlier. We wouldn't want all of the species to be evolving towards higher complexity. There would be no stability. You need all of the species sort of playing their role the way that cells, if the biosphere is an organism, Gaia, then you need it the way that cells play that role in the body. And if red blood cells were evolving to become increasingly complex all the time, that wouldn't be very helpful. Um, so we need this variety of component parts, because variety has, so if it was life, you can't get life out of all carbon atoms. And if your body was all one cell type, you would have no variety. To have something complex, to have a machine, to have a car, it can't be made of all the same parts or all the same materials. You need variety. So this whole point about variety is stressing the fact, well, first of all, that the nations need to come together, that we need to preserve cultures and stuff like that and individuality, but we need to come together as well and share that knowledge. So coming together doesn't mean losing individuality. That's an important point. But that when we spread, it's not just going to be like humanity, like taking, like our species taking over. We're going to become more varied. And if there's other intelligent civilizations and agents out there, I believe we will collaborate and cooperate, because I believe that anyone that's reached that level of intelligence will understand this kind of computational story of the universe, and that almost immediately there might not be as much war as anyone's thinking. I think there could be, but it could be like, oh, that's going to increase my computational power. Like that civilization is, we're about to share information and we're about to make a super organism that has experiences, that's capable of experiences that are psychedelic beyond belief. Like I think the future is going to be an extremely psychedelic place. It's not going to be a cold place. When I'm saying life spreads, I'm not saying it's going to be like these automaton things spreading throughout the universe. I'm going to say I believe it's going to be extremely deep and experiential reality where agents are combining and having all sorts of co experiences. I mean, integrated information theory talks about being able to kind of link up with the brain of another individual and form this kind of higher mind. Who knows if that's possible? But yeah, I think the people concerned about that, I mean, it's just like, I think it's a wrong interpretation. And um, what do they want? Life not to spread and like life to die out and just have a cold, sterile universe where love and experience and consciousness doesn't exist? I think the best story for the universe is that life and intelligence and consciousness spreads. And fortunately, I believe as that happens, we do become more compassionate because being intelligent is understanding that there are other systems that are like you. So I do believe that there's this moral trajectory and that we're going to become more moral over time. But unfortunately, it takes mistakes. It takes a genocide to understand the problems with genocide. Like we had to learn from World War II. It was probably inevitable that a Hitler-like character would emerge. If there's other biospheres, they probably had a Hitler-like character. I think because of convergent evolution, if you look at the trajectory past, if there are other intelligent civilizations, I think we would be shocked at the number of similarities. And I think Stephen Jay Gould is completely wrong about everything being so contingent in the biosphere. I actually think that because there's this design, which we'll talk about now, that there is a trajectory that kind of, you have a biosphere, which is a distribution of attractors. So I think on another biosphere, you would get a very similar distribution of species, and there would be the trajectory of species over time would be similar as well. Um, yeah.
What one final thing on the idea of kind of life going on forever. So I think I have a different take that is maybe similar in some ways. So my instinct is, so Sean Carroll has this paper about how complexity relates to order and disorder. And the idea is,
Yeah, I don't like his thing. Yeah, the cup, the coffee. Yeah,
so
I think that's
exactly.
wrong. Yeah,
So for the audience, you add cream to coffee, and you see all these kind of fractal tendrils, and you get increase in complexification, and then so it follows an inverted U shape, right? You start with low complexity and high order when they're separate, and then they mix together, and the complexity increases, then it decreases. In that resonates with me, and that kind of impermanence of complexity seems to be everywhere. And so if you have this bell, instead of inverted U, call it a bell-shaped curve. It feels like we're on this upswing towards complexification, and my instinct is that it will come back down at some point. Whereas it seems like you're saying it's actually just kind of exponential. It will just keep going up and up and up. But I also want to say
there could be a limit, but I think it's going up towards a fully integrated state of the system, which Sean Carroll's thing does not say. It's just it looks at it like a model of gases mixing or something. It's just mixing. Here's the problem. The cup of coffee exactly precisely lacks adaptive information. It lacks the whole thing that I'm saying emerges, and that's the special thing that takes over the whole universe. So if it was an inanimate universe, absolutely right. Planets, stars would form. But when you have life and you have these information processing systems that are adaptive systems or learning systems, they just spread and subsume the system. And then the model isn't so much like a gas, like spreading and, things mix or some complexity, and then it goes to disorder. It would be more like a dissipative structure that forms, and then it forms this whole pattern in totality. And really, you could keep a dissipative structure going forever. I mean, as long as you heat something like a liquid, you can heat on like your stove, you can create like a dissipative structure. that keeps going as long as like energy is being supplied. Um, you don't see that I mean, in nature, like the storm on Jupiter has been going for like many hundreds of years. Um, but so there's been people, for example, in James Gardner's book Biocosm, which got great reviews from cosmologists and people like Martin Rees and Paul Davies. He argues that the universe is going towards this self-aware state. He argues it with this kind of mechanistic, naturalistic story that I've argued. And he thinks that this self-aware state, like that it's approaching toward, like leads to the creation of a new universe that is also teleological, that like it's kind of like to birth a new universe with the same, similar to Lee Smolin's cosmological natural selection theory. So the point I'm making here is that I do think it's the universe is approaching this fully integrated conscious state where it's like an organism. It's developing right now into an organism, and there could be a limit to that. So it could be similar to that where you have that, but I don't think that it will end before it propagates itself, creates a new universe, life spreads to another universe. Um, but there is also the possibility that life could just continue to spread forever, that the universe is this system that basically um, just kind of remains in this dynamic equilibrium. And well, yeah, it gets pretty tricky. In the article I talk about how the universe is expanding, but people think there's a new theory called quintessence that Sean Carroll has said is convincing, that says the expansion of the universe is going to slow. And so if the expansion slows, then it's much easier for life to spread through the whole universe and to become this integrated network. But then the question is, can it just kind of, can you have new matter and energy created while it keeps this dynamic equilibrium forever? Like, I don't know. David Deutsch seems to think that there can just be knowledge creation forever. So I'm not completely tied to the idea that life has to go on forever in this universe, but I do believe that I mean, that's what I make the argument for in the article. But it seems to me that once we get towards a state close to that, then life basically can start to manipulate the laws of the universe, like in ways that it's hard to make predictions about, like what sort of limitations there are, because um, these new papers that are coming out, like Lee Smolin and Jared Lanier, that says the universe is this learning system. It says the laws aren't even fixed; that the universe learns its laws, and that the laws could change in the future. So we're at a time where there's complete uncertainty about the universe, and we don't know what dark energy or dark matter is. But I believe the picture that's emerging is that it's something like an organism. And Sean Carroll's model is based on the universe being something like a gas in a box, something like an inanimate system that's not an adaptive system. Um, so I think that's where we're headed. And I think the ultimate state is a fully integrated state of the universe that maybe has some sort of purpose. Maybe it's the reason for this, it's approaching that, but that the universe itself may become a conscious entity. And if it does that, it's equivalent to a god. And Freeman Dyson, famous physicist, said God is simply the name that we give to an agent, to mind when it's exceeded our comprehension.
And so does this bring us to the deism piece of the kind of intelligent design?
Yeah. So I do think there's a design. People can look up the fine tuning mystery, and basically there's all these parameters that if you change even a little bit, you won't get a universe with life, and you won't get a universe with really structure. You won't get a universe with like stars and planets. In most cases, you won't get a universe even with like atoms, really. The universe will just expand forever, like super quick, or it'll condense into like a singularity. So if this is the only universe, then it would be designed. You would be forced to that conclusion, because it'd be so improbable that, because if you wanted to imagine all of the possible parameters of every possible that could a universe could have that would give rise to all these laws. And if you just arbitrarily picked out values for those parameters, you would get billions of universes, trillions of universes without life, and you would get a few with life if we only made trillions, let's say. Most would be completely lifeless and structureless. So if we're in one, given what we know about these fine tuning things that a lot of people just ignore, there's been like, some people have tried to debunk them like skeptics, but of course they don't at all. If this is the only universe, then it's just overwhelmingly improbable that it's a life bearing universe, given what it takes to make that happen. And that's why the multiverse theory is so popular, because it's the only solution to the fine tuning problem that preserves the idea of a nihilistic, meaningless, random universe. And it says there's tons of universes out there, and we happen to be in the ones that are that support life. But you have to do that. You have to explain it in terms of a multiverse to explain the fine tuning problem.
But doesn't cosmological natural selection provide a
Yes.
non-design?
Yes, that's another one. But so I guess I was saying traditionally, I have to plug my computer. Traditionally, there were kind of two explanations. It seemed to be design, creator, and then we find out fine tuning. And then in the 70s, people like Martin Rees, Paul Davies were like, holy crap, fine tuning seems to bring design back in. And Paul Davies wrote books like The Mind of God and got a Templeton Award and stuff. And if you read those books, you will see why very respected physicists understand that the fine tuning problem is a very serious, real problem. And Stephen Hawking's collaborator just came out with a book that's about, like, I have it somewhere. Stephen Hawking's Stephen Hawking changed his mind. Stephen Hawking's final theory was a theory that life matters and that the multiverse solution is not a good one because, first of all, it's not testable. And so he basically says that having this model of all these universes just to explain away like the designer thing is not epistemologically sound. So he goes this different direction, basically goes in this John Wheeler participatory universe direction, and basically says like the observers basically bring reality into existence and turn the quantum world that's not very tangible into a real world. And there's sort of this backward causation that the universe looks like it does. And, because we're here, and that the other universes without observers aren't universes that are realized in like tangible reality. So it's pretty radical. And I don't think anyone has fully understood what that book is saying. And I'm going to talk about that more. It's in the Big Think article. I mentioned it because they do say the universe is a self-organizing system that learns its laws and that evolves in this Darwinian way. Huge thing to go from brief history of time where life is chemical scum to saying that the universe is fundamentally bio-friendly and that it's a self-organizing system. So Lee Smolin came up with this cosmological selection, natural selection theory that said maybe there's this Darwinian process that can explain the life-friendly nature of our universe. And in that model, you have a universe, we think that the universe began with a Big Bang, which is a singularity event that created our universe. So the idea is when a black hole forms in our universe, that's a singularity as well, that creates a Big Bang event that produces a new universe that's kind of like a pocket that's formed out of our universe. It's sort of the progeny of our universe. And that universe will inherit the parameters of our universe, but with a little tweak. And so you can get reproducing universes that then become more life-friendly because the conditions that give rise to black holes are also the conditions that are friendly to life, because to have black holes, you need stars that collapse. If you have stars produce the higher elements, which make life possible. So the idea is that our universe is life-friendly because as this universal cosmic natural selection process played out, meta-universal, I guess you could call it, we would get universes, the new universes that are being created would be populated mostly by universes that allow for carbon-based life. So that seems like a nice Darwinian explanation for the fine tuning of the universe. But here's the problem with that. In Lee Smolin's model, it's not a problem. I like it. But here's why I think it's not that different from design. In Lee Smolin's model, you have a universe that inevitably gives rise to other universes, which inevitably give rise to life bearing universes. And then because intelligent so if this model's right, I didn't mention this, and there's been some physicists who've taken Lee Smolin's theory there, and he likes going there too. So he likes this, but he is hesitant to talk about this aspect of it because he goes, "I don't want to go there yet. I just want to prove the black hole part. I'm going to keep it simple first." But if you push it to its logical conclusions, if black holes create new universes that inherit the parameters of the parent universe, when you get an intelligent civilization that can create black holes, that can create baby universes, then those start to dominate this multiverse structure because they can create way more than would be created naturally. So, if you believe in this story of cosmological natural selection, you have a universe that starts out without life, but then it inevitably produces a universe with life, and then and then that life bearing universe starts to produce increasing teleological universes, like universes that grow more complex. And then if you look at the structure of that, life dominates it and spreads, and then starts to spread throughout the structure of the that new Darwinian multiverse. So you have the same teleological story that we were trying to explain away, where life emerges inevitably and spreads through the cosmos. You just have it at the level of a multiverse now. But I like this explanation better because it explains why we should expect to find ourselves in a universe that grows more and more complex, because now it's not unlikely. Now, most universes at this point in time in the evolutionary process are more complex universes. So I think it's a great explanation, but my problem with it is it seems to lead to a teleological multiverse that would then beg the question, why does it have those meta laws? Because there would be laws that would allow for that. And then so George Ellis and Paul Davies had talked about that problem too. So I don't think it gets rid of the design problem, but I do think maybe it can allow us to just say, this is the way reality is. It's fundamentally life friendly, and it generates consciousness, and it generates stuff forever creatively. And if you only want to go there, to me, that's deep enough. That's spiritually satisfying. I go, okay, well, then life is kind of like, I mean, the universe is kind of like God. It's creative. It's like, it's not a nihilistic, pointless universe where life comes and goes. It's this life generating universe that creates not everything arbitrarily, like just like everything, like it produces life and meaning and purpose. And so that would just take pantheism to a whole new level, because people, Spinoza, the universe is like God. Einstein believed that, but it was kind of this inanimate world that wasn't very, special in the way I'm describing. If it is this way, then it's like a whole pantheism on spiritual steroids, and I like that too. But here's where I finish it. Here's where it gets a little bit more complex. That story will lead to universes like ours where we're intelligent agents, and we're starting to create virtual worlds. We're starting to create our own realities with agents in it, and maybe we can make those conscious agents. Maybe we can, maybe if normal computers can't make conscious agents, maybe we can run it on neuromorphic hardware or biological hardware. So the point I'm making is, once we create worlds ourselves, we've demonstrated that mechanism is possible in reality. And once we demonstrate it's possible in reality, we have to consider the possibility that we're such a creation, because we've now demonstrated it physically. So some people might think, oh, well, you're saying it's kind of like simulation theory. We could be a simulation. Yes, but I'm also saying that would imply that we're the creation of an intelligent agent. And so that the simulation theory becomes effectively an intelligent design theory, and that there's no meaningful distinction between the simulation theory and an intelligent design theory, where it's a deistic theory, not a theistic theory where you put God as the creator of the system that let it evolve. So my final point, well, kind of, maybe not, but getting there, because I know we've been talking for a long time, but this is the cool stuff. Cosmological natural selection or even a multiverse theory where every possible universe is realized. I don't like the multiverse theory though, because it seems like it leads to more ridiculous things than a creator, because you just said that creator, that's the simulation theory. It's no different if you don't have all the wacky stuff. Like that's uh pretty reasonable explanation, is that there was a creator. Now that we've created stuff ourselves, it's not supernatural anymore. We just extend reality and say this world is in a base level reality. So the whole thing about designer being a supernatural theory, that's gone out the window. And what I'm saying is, this is a naturalistic position that I'm trying to argue that what used to be the supernatural position can be redefined as a natural position. We just have to extend reality, and we have to understand that realities can be created by sufficiently intelligent agents, and we're doing that. So if you have cosmological natural selection, or you have the multiverse theory, it's going to lead to universes that have agents that are intelligent enough to produce their own worlds. And so we can't get rid of the scientific possibility that even if cosmological natural selection is true, that our universe is created by an intelligent agent in base reality. So my argument is that reality's structure as a whole seems to be life bearing. I mean, like life friendly, not just life friendly, but generating life that, even if it ends in this universe, it would seem to propagate elsewhere forever. And I think that's equivalent to God. And hopefully, so I've explained God and why I could possibly believe in it. It's a theory. As like a Bayesian exercise, I would be like multiverse, cosmological natural selection, designer, and like those are all fine theories. The simulation theory is an intelligent design theory. The last I just want to make one point about the multiverse theory, why I'm not convinced by it, because everyone will go, well, why do you need that if you have the multiverse theory? The multiverse theory answers the God question by introducing more absurdities. It goes, yeah, there's not a God because there's not a designer. You're just here because you're one. This universe has one of the combinations of parameters which allows for life, but like there's every combination out there. So you would have universes that have you in every ridiculous scenario that could imagine. You would have everything that you could ever possibly imagine. Here's the weird thing. If you really want to take that multiverse thing to its limits, logical conclusions, you would also have universes that have creators, which create things because we're in that universe. So the multiverse doesn't get rid of the God problem. God, there's still room for God, for, creators in that world. But then it introduces every universe with every absurdity you could think of. So to me, on Occam's razor grounds, and this is what Stephen Hawking's collaborator, he said they came to the same conclusion, it's epistemologically inferior. It introduces all of these untestable things and more intellectual baggage, philosophical baggage, than the simple idea that this universe is created by an intelligent agent. So, yeah.
So I resonate with the thing you said about that you're kind of naturalizing this. To me, it feels like naturalizing kind of the Western religious tradition with the emphasis of kind of humans being at the center of this story and immortality in the sense of that death is some kind of illusion, and what we are will go on forever, and also this naturalizing of God. And I think that that's maybe a good way to describe the difference in our perspectives. Is mine is more a kind of scientific defense of more kind of Eastern and indigenous perspectives around impermanence and circularity, and so. But the flip side of that is, even if there's impermanence within our universe and it does end in heat death, I think I'm very sympathetic to the cosmological natural selection idea. I don't think it makes sense to think that our universe is the totality of everything that ever could be. I think there will be something else after it, and forms will always form. And so the kind of thing that we are will always emerge and be present. So yeah, as you said, we've gone for a while. Is there time to talk about consciousness, or what do you think?
I'm good. I didn't want to bore anyone or take up too much of your time, but yeah, we can do that, because I was going to say that's the kind of the thing that one thing we haven't talked about.
Yeah. Let's touch on that, and then we can wrap up there. Because so as we spoke about offline, my stance is a kind of biopsychic one, in that I think that consciousness is tied up with this kind of inference process of life. And I know you think that consciousness has causal power, that believing, you mentioned kind of sending a rocket to destroy an asteroid, right? And that's a good example of the knowledge we have, the kind of information instantiated in living systems causing something to happen in the physical world. You can't explain that in a reductionist way. So we completely agree on that. But then that's not quite the same thing as consciousness. Conscious experience, just being consciousness, being experience. And so, but I would say it's linked for me in that when an agent does something and you appeal to something like pain or suffering or pleasure, to me, if you're going to create a kind of zoopsychic narrative where it requires a nervous system or not all life has it, that's when you kind of create the hard problem for yourself, because you're then kind of saying this mechanism that plays out in simple organisms for some reason doesn't feel like something, but it does feel like something when there's a self, when there's the ability to recursively model yourself. So I think is that the crucial piece that you see being relevant, that there's some kind of recursive process of self-modeling?
Yes. And this is where we differ. As far as I know, this is the only point where we differ. Other than the well, yeah,
all the other
the
stuff
big
we spoke
point about whether it's impermanent or not. Yeah. Okay. Well, yeah. So, but we agree on all of the complexification stuff and kind of the mechanisms, evolutionary mechanisms, thermodynamic mechanisms, and some of the inevitability, the inevitability of the earlier emergences. Okay, so I kind of started with like a panpsychist position and wrote an article in like 2015 that I published at Huffington Post in Psychology Today that was explaining integrated information theory and how this theory kind of revives panpsychism, or a kind of a neo-panpsychism where there's consciousness wherever there's information processing. And then the idea is that there would be minimal information processing in systems that we consider to be inanimate, and definitely in systems that are super simple, like a cell, which we consider usually to be unconscious. And I was excited about that. So there's this hard problem of consciousness, like how can you explain consciousness suddenly? Like if it's emergent, that's kind of weird. How does it just like poof into existence? And that seemed kind of hard to explain, as you mentioned. And so there's this idea that maybe it's easier if like everything has a little bit of consciousness, and then when you have an aggregate system at a larger level, the consciousness kind of adds up into this larger consciousness. And that sounds reasonable enough, but in writing the book and really thinking about the mechanisms, I started to change my mind. So I thought that consciousness pretty much emerged with the emergence of life. And I was sympathetic to panpsychic ideas that maybe there could be just like a modicum of consciousness, but it wasn't really meaningful to talk about, but that at some low level, maybe an atom or a thermometer would at some, have some sort of experience that was so basic it would be just kind of like your eyes closed or something. And so the reason I changed my mind was because, so when life emerges, I understood that there was this phase transition where the system becomes this computational system, and information kind of changes the causal architecture. And that information gets built up to a variation and selection process that we see in a chemical system evolving in a way that's similar to how biological systems evolve, but it's basically self-organizing. And you have this dissipative adaptation process that Jeremy England has described. And so through evolution, you get a system that can start building up these correlations with their environment that we mentioned earlier. And those correlations, that's knowledge, because that information is predictive of the environment, because the correlation means that there's something shared by the organism and the environment. So just to be clear on what I mean by a correlation, you could have an organism, a single-celled organism that swims in random directions, and it's just very simple. It just moves its tail and then randomly until it detects food, and then it stops and feeds. You could imagine an organism that instead of moving randomly, goes in the direction that it sees something moving. It gets a visual signal and it goes, oh, I see something on the right. I'm going to go in the right. That would have a selective advantage in some environments over the one that moves at random. And that would make more copies of itself. And that's a statistical correlation. Now something environment goes right, it goes right. But you could have correlations in like, oh, it has a mutation and then it gains a fin instead of, a smaller structure. And then the fin pushes the water. And the fin is like correlated well with the movement of the water such that it propels the thing because it's shaped in a way that, pushes the water with the maximum amount of whatever surface area, who knows. But so in that way, evolution builds up these correlations between organism and environment. That information is encoded in the organism's genome and its dynamics, maybe in its metabolic processes and the structural dynamics of the system as a whole. So there is memory outside of the genome. So yeah, sorry, I lost my train of thought again because I keep going on these. Oh yeah, so you have, yeah. So my point is you have agency because agency is basically goal directed movement that's built up through these exploration of different functions. You have a genome that's kind of randomly evolving. It's pretty random at first. It's not completely random later, and maybe that's too much to get into here. But you have these little, mutations that give these different functions, and the ones that get selected are the ones that are correlated. So the thing becomes predictive of its environment. And since the one that had the mutation that makes it go in the direction of something did well, it'll make copies of itself, and then the offspring will do that behavior too. So it'll have this agency. It'll be like, oh, it goes towards this thing. Inanimate systems don't move on their own at all. They don't go anywhere. They don't have goals. So there's something unique about life, and it's in the information and its agency. And so I thought agency and consciousness come together as like a package deal. But then I started to think that you have this intelligent behavior and it is aware, maybe not, I'm going to say not having an experience. I'm going to argue that it's not aware, but that it's responding as if it's aware. It has a sensory response that's knowledgeable to its environment. But the reason that I thought it didn't have experience yet is because what I came to believe the mechanism underlying actual experiences is that it's not good enough for the system to have this sort of knowledge base or model of the world. That's just this, just information about the environment, that the model will have to contain a model of itself. And this is largely based off Douglas Hofstadter's work in Gödel Escher Bach and stuff. Basically, he argues that self-reference brings the self or the observer into existence. So what I came to believe is that if you have an information processing system, like life is where intelligence starts or cognition, you have agency, you have intentional behavior, it looks conscious, but that without brains, the genome can't really create a model of itself as a causal agent because it's born with a fixed genome and it has certain behaviors that are programmed in developmentally, but it can't. So, for example, if you reach over and you knock your glass off, like your brain records a memory of how that happened, and then you don't do that again because it can create memories in real time due to synaptic plasticity of the brain. Genomes don't have that, so things can't learn things. Like you might have certain bugs that just walk, and like, roaches get scared when they see you, but certain bugs don't get scared when they see you. They might run from a different bug, but for whatever reason, they don't have the variable that is you built into that model. So it's kind of fixed with genomes, but with the brains, we can create new memories in real time. And that leads up to building up a model of ourselves because we go, oh, we just acted on the world and we record a memory of what we did. And then we incorporate that into ourselves. And that gives us understanding of ourselves as a causal agent. When we're just brainless organisms, we have a genome and we're doing behavior, but I'm arguing we're zombies. We're unconscious systems behaving intelligently, but we don't have the awareness because the awareness arises from the observer Like to have a self, to have a perspective, you need a system that models itself, because it's actually the model looking at itself that creates the perspective. And that's the hard thing to explain. So you have a model modeling itself, and that's that self-referential loop that, I guess, animates or generates the world of experience. And so it's not anything magic. It doesn't merge, it does poof into existence, but the same way that like you're creating like a TV and like your or a computer and you're wiring it, and like the monitor comes on and I can see you. But if something happens with the computer, I get water on it, like you disappear. So like that's emergence. Like things need to be happening together. And then that visual representation pops into the world. I think consciousness is the same way. And um, so experience, I believe, subjective experience, that hard thing to explain is the perspective. How do you get the eye? I believe the eye requires pretty sophisticated modeling machinery, and specifically the ability to self-model. And so that's why I don't think panpsychism is right. And I also think like a good argument against that is like when we go to sleep before we start dreaming, we have a period where we're not conscious at all, or some would argue. I would, we lose consciousness, and it doesn't seem like we're minimally conscious because we would notice a duration, but we're just gone. And then when we dream, there's a duration. We know like, oh, I was in that dream for a long time. Sometimes it seems like that. But my point is, if the brain is unconscious when it's still alive, where it's still physiologically working, but there are moments where consciousness drops out, I have no reason to believe that a rock is conscious. I think there needs to be a specific functional architecture that's just not just integrating information, but also doing this sort of loopy self-modeling to bring a self or an observer into existence. And again, it's nothing supernatural, though we do start in all of these things. What I'm trying to show you is like my position is a naturalistic position, but what I'm saying is if you consider reductionist conception of nature to be naturalism, then it's not naturalism. But what I'm saying is we have to expand our definition of naturalism to include, for example, consciousness. It's subjective experience. It's not exactly physical in the way we think of before, but it is also something real that we're experiencing, and it has a physical substrate. So it seems like it's natural. So is it physical or not? Depends on how you define physical. Is it natural? Well, yeah, it emerges in nature. So I'm comfortable with calling it natural. But in the book, I call the philosophy that corresponds to the integrated evolutionary synthesis poetic meta-naturalism, based on John Carroll's poetic naturalism. But the reason I use meta-naturalism is kind of a paradoxical term that I thought got at this issue of the fact that what we define as natural at the moment, there's going to be phenomena that emerge in nature that force us to expand that definition, and subjective experience is one thing. So when we say, oh, is this natural? Someone might say, oh, you have a supernatural theory of psychic phenomena. I wouldn't bet that psychic phenomena is real, but if we discovered that it was real, it would have a physical mechanism underlying it. And that might be quantum entanglement. But if we did find out it was real, and then we looked for entanglement and we found it, suddenly all of those people that said, oh, I hate your supernatural theory, now they'd have to go, oh, I'm sorry, it was never a supernatural theory. Psychic phenomenon was real. It was so rare and we didn't know how to test for it. We didn't know what to look for. And now we see that it's real and it's natural. It has a physical mechanism we can understand and reproduce. So another thing that was really eye-opening for me in writing the book was that I understood how tricky language was and how much it has been a barrier to like new ways of thinking. Really, the mind-body problem, dualism versus physicalism, it was all based mostly on a language issues, because there's no clear definition for what natural is. There's a lot of people that would say a naturalistic theory says consciousness is an illusion. It has to be an illusion. They're only particles. And then other people might be non-reductive physicalists. They're like, well, consciousness is emergent, but it's real, so it's physical. I think those are kind of unproductive conversations. We should realize that reality is sort of multi-level. So I call what's in the book multi-level monism. There's like one substance, but there's all of these different aspects that emerge from that in different phenomena and properties, such that there are new things that come into existence that we need to call natural because they're part of nature, but they would not be considered physical from the traditional materialist perspective.
Yeah, we definitely share our intuitions around consciousness being a natural phenomenon. And to me, it really seems as simple as people who are digging their heels around reductionism are basically being supernatural without realizing it. The tendency to think in supernatural terms is really insidious. And without realizing it, people say there's something magical about particles. They have causal power and they're the only things that can and there are absolutes like space and time, and they just kind of posit things as brute facts in the same way you might posit a belief in God without any evidence, without a theory
Yeah.
or explanation that you've been given. Yeah, just so on the consciousness thing, the extra thing I think that's useful to think about is when there's experience without a self. Consciousness doesn't disappear when in meditation with psychedelics. When there's no self model, consciousness still continues. So to me, I see the self as an optional extra cognitive process of self modeling rather than a necessary ingredient
Yeah.
of
So
consciousness.
let me just say something real quick on that, because that's a point of confusion that arises when I say this a lot, and it's my fault. And I try to explain this in the book, but it's really subtle. So when the brain's recording all of these responses to your actions while you're learning, just it's reinforcement learning, that experience dependent plasticity that you're learning through life. You become more and more conscious and more aware, or more and more self-aware as life goes on, because you're learning and you're building up that model of yourself. um so when I say the brain's doing self-modeling, I'm not talking about self-awareness. I'm not talking about an awareness of yourself. I'm saying it's building up kind of a registry of variables, or kind of understanding that you're a causal agent at this like lower level, that you act on the world, and then it records those responses of that action, and then you have a self model. So when you do psych, and so then there's another level of self-awareness where you actually have an awareness of yourself as like this conscious agent. So what I'm saying is self-modeling gives rise to basic consciousness, not self-awareness. It gives rise to kind of epiphenomenal consciousness, just an experience. So when I say self-modeling, I'm not talking about the high level self-modeling that you're saying goes away. That would I really need two names to say. One is like modeling of yourself as a conscious agent, and one I'm just saying modeling yourself as a system where you're like registering yourself as like having an effect on the world. So when you do psychedelics, I don't think that other thing goes away. I think you still have like it's a stream that is like caused by self-modeling, but the self, the higher level I, does dissolve. But so what I'm saying is the other level of self-modeling that you're saying goes away, I'm saying that level of self-modeling is kind of responsible for this higher level of agency. That's where you get like freedom in your agency. You're not just like this algorithmic thing. And I associate that in the book with like cognitive control and executive control. You can kind of override your biological programming, such that if like someone angers you, you won't like smack them, like you override that reflexive behavior because you have this higher level self that lower animals don't have. And when that dissolves, you're left with this automatic mind. And I think that's what's going on in psychedelics. You dissolve the higher self and you're still left with consciousness, but it's a more basic type of consciousness. And the higher self, the I that's responsible for executive control and all these good things, it also does bad things because it is really responsible for understanding you as an individual, and it kind of dampens the interconnectedness of nature. And that when you remove that higher level self, it's basically you with that more basic model. But I do think there's still low level self modeling that's going on. That's basically just like the system is aware that it's like attention of attention. That's still there with psychedelics. and the self that dissolves with that is like the higher self that emerges from a higher level of self modeling.
Right, that makes sense. But
That's
the
kind of
other
true.
thing I would say on that is that I think the idea of simple organisms as being kind of like bags of reflexes that just kind of move reflexively on chemical gradients. I think the image, the picture we agree on about life, I think that picture actually entails that they are far more like us than we would typically think. That even a single-celled organism is doing some kind of self-modeling, is making decisions, is acting intelligently, and that teleological process of self-perpetuation is the engine of intelligence, of agency, of and I would argue experience as well. So
Yeah, absolutely. I agree with you with everything but the experience thing. So yeah, I just see them as agents. Like once you get life, you have agency, you have intentions. But I do think those single celled organisms and people have, experts have said they do some, not self modeling at our level, but some minimal amount of self modeling. But I don't think it's the self modeling that I'm talking about because basically, like I said, the genome is there's some epigenetics that allows for changes, but you don't have a structure that's in real time recording the effects of your actions on the world. And I think that's when I'm saying modeling the self, I'm saying registering yourself as a causal agent. So if you're a brainless organism and you bump into something, you don't learn that's there. You just keep doing this algorithm that is what you do. So that sort of self modeling is absent. So I do believe that they model the world, but I believe it is more of a reflexive uh, thing still. But yeah, there's no real experimental way to get
I don't know. I mean,
at
if you look
it.
into plant
If
intelligence
I am, I
research,
will say one good thing about it morally. If I am right, then we don't have to be that as concerned. Here's the thing. If this model I'm saying is right, then consciousness increases as you get more intelligent, which I think you would agree to. And we should that's because a lot of people don't want to become vegetarians because they're like, we don't know if some things if a lot of people don't even know if lower animals are conscious. They might think chickens aren't conscious. They might be fine with eating them. And some people might say, well, I'm not going to go vegetarian because that's ridiculous to stop eating all things. But if you take this idea that consciousness is correlated with intelligence and complexity, then you suddenly have this prioritization um, thing. Like Douglas Hofstadter has even created like this pyramid, which kind of he puts at the top the ones they think are more conscious. So I think it's smart to think about what leads to higher consciousness because I do think that some things are more conscious than others, and that gives us a moral compass sort of to start prioritizing which ones we don't eat first. Mammals, squids, octopus, smart things and things that have less of a capacity to suffer, we'll worry about less. So the good thing about this idea, even where we both agree, is that it's a little bit better morally to eat shrimp than to eat beef. Um,
yeah. So actually,
and
I don't share the intuition around. Well, I do think that with intelligence, the complexity or the different number of kind of the repertoire of conscious states increases, but I still think that pain is basically the same. The level of suffering of a bacterium
yeah,
being boiled alive is similar to me being boiled alive. That's my instinct. I know that's not a common intuition, but because it leads you to
yeah, it's kind of
confront a huge
tricky.
amount of suffering in the world.
Yeah, I know why you would think that because probably the pain signal, there's no reason for the pain signal to be any less. But I think a lot of the experience of pain might come from the sophisticated cognitive machinery that is responsible for intelligence that makes us feel pain more, just as if you were given some sort of anesthetic to, you're not going to feel pain because it's just deactivating certain areas of the brain that are responsible for processing. So I'm not sure about that, but I don't think it's a perfect correlation between intelligence and experience. So I'm with you there. One thing I was also going to mention is if single-celled organisms aren't conscious at all, well, we're not really killing them much, but I mean, this applies to ants, and I do think
I don't
ants
know.
are
When we wash
conscious
our
because they
hands,
have
we're killing
brains.
bacteria, so they would be suffering every time we we wash our
Yeah,
hands.
so that's one good thing about this is bacteria don't suffer. We don't have to worry about it if this is true. And that would make sense to me if I do think there's this kind of larger mystery, this kind of moral arc. Part of me suspects that this is by design, that like we have to accidentally kill the things that have a less capacity to suffer. So if we went out and there were like frogs all over the road, covering the road, we wouldn't go jogging. We would feel bad, like killing frogs. And if it were like dogs laying down for whatever reason, like we would feel even worse. We wouldn't ever do that. But I don't know any vegans who don't go jogging because they're killing tons of ants. And that would be terrible if ants suffered as much, because it would literally be like just stomping dogs every jog, killing hundreds of
Well,
dogs.
that's what the Jains do, right? The religious group who they kind of drink through muslin to make sure they don't kill insects. So there are some people, but it's a minority position.
It's fascinating, but I think we can make a strong argument now that would show that basically you can say that there is some correlation between capacity to suffer and, cognitive capacity, such that, those people don't have to be doing that. I mean, but it's great for us because it would be a nightmarish world if we were going for a jog and every ant we stepped on was feeling what, so yeah,
So I think that's actually a really important. That's a really important point. I think that the place we're at now, the conversation is there will never be a final full stop on consciousness. Like people will have different intuitions, I think, and we may get very close to agreeing, but I think there'll still be some panpsychists. There'll still be some, because you're never going to prove it as a certain fact, right? We may come to a kind of collective narrative we agree on.
There may be some way we just have no way to grasp right now, but
right
now there seems to be no way to prove it.
But so at this point,
but we are imaging brains, and where we can put on screens what people are imagining. So this kind of hard problem of consciousness, we can't see other people's qualia. Like, I'm not sure if that's going to last forever too.
Yeah. But so where we're at now, the thing you just said about being a nightmarish world, I think these issues really tap into deeply emotional things. Like if to entertain certain hypotheses involves you empathically sitting with the possibility of unimaginable levels of suffering. And I think that unconsciously biases our decision making. So I think that this is it's going to be a tricky thing for us to agree as a
I think we need to figure it out, though, because
yeah, I agree.
One of us is right. And I don't know who it is.
And it's important who's right.
Yeah. And in 100 years, they might know which one of us knows which one of us is right. In 100 years, they might pick the wrong one, and it might take 300 years to know. Right. But I think we can put all the facts down and start to get a grip on where it emerges and where different levels of experience emerge. And that's what I try to do. And not everybody's going to accept it. It's interesting because I make this argument, I'm not saying that you shouldn't keep your view. You should keep your view. You have lots of reasons for keeping your view, and they're good reasons. But I do have to comment on the fact that I don't think my explanation has changed anyone's mind who has talked to me about this, who already had a belief. And they haven't changed my mind either. So I can't really complain about that. But it does seem to be hard to get people to change their stance on this because there's so many reasons. There's usually lots of, like, for example, I just told you a reason why I love my theory from a moral perspective. I don't have to worry about killing ants as much. But so there are these biases, but it is kind of worrisome too that, no one goes, oh yeah, that self-modeling thing makes sense. And oh yeah, that's a good reason to believe that too. And like, oh yeah, I'm going to, so, that's just the nature of humans at this point. But I do hope that when confronted with, all of these facts that we assemble, which I haven't done, I did some in the book, but not enough to convince everyone, and not enough to convince myself. But that's the problem too. I did all this research, and that's the conclusion I did based on all of these facts, which I can't get out in this amount of time. You've done tons and tons of research, far more than the things that I've told you. So, you're not going to give up your Bayesian prizers for an argument, an hour-long argument, when you have all these other reasons that I can't unpack. But I do hope that people, that we all make an effort to be like, let's try to put these puzzle pieces together and then go where it's showing us to go. Because I do think this is the solution for, especially for people who haven't thought about it at all. Because most people are like, I'm not going to go vegetarian because I don't want to not eat all meat. But if you told people like, hey, this squid is like super, super smart, they can do this and they probably feel and like, like close to human intelligence or like a 3 year old and like a dog, like then they'll go, okay, I'm not going to eat a few of those things. Like imagine if this is true, which I think it is. I think cows suffer a lot more than chickens and shrimp. Um, uh, and and I think dogs suffer even more. So I hate the idea of like people eating dogs. And when you see those like wet market videos and stuff, like the dogs aren't anesthetized. And when I saw the video, I was just like, man, it's just like seeing a video of the Holocaust. It was all these dogs and they're just about to be like slaughtered at this market, like just totally yeah, I just can't believe that's still going on. But if beef, and I'm kind of a hypocrite because I eat beef. I've been vegetarian for certain years. Like I had experience with like a cow. Like I bonded with a cow in a farm in Switzerland, and I didn't eat beef for 2 years. Um, but if those things are really suffering, and we can decrease suffering a lot by having all these advertisements, like, okay, everybody, you can eat meat. Like we're not asking you to do something that you're never going to do anyway. We're going to say just like let's cut out octopus. Let's make that a law because we've proven they're intelligent. That would be a big step in the right direction. And we need to start making arguments for things like that and actually implementing them. And if we don't, if we just let vegetarians with no theory just go, you shouldn't eat anything, that's murder. And when you put a nail into a tree, you're hurting it the same way. Because if people have this equivalence that I'm hurting, like a cow is the same as a tree or a plant and I'm going to eat an apple, you're telling me not to eat like or whatever. Now that's kind of ridiculous, but I'm just saying when people have no idea and they see things as equivalent, they're just like, I'm not going to do it. But if we really explain to people and if they really knew, or if we brought people and let them play with these animals or let them watch videos of something, like then they would see the importance of that and they would start to cut out the things that matter. So there's a practical reason to have a theory of consciousness that the public understands. Like these things matter every day, they matter. And we're living in a world of ignorance that allows us our conscience to be okay doing things that we would feel immoral about if we had a better understanding of what was actually going on.
Yeah, I think that strategy makes sense, irrespective of the theory of consciousness as well. That you want
Yeah.
to increase the circle of compassion based on what you most empathize with. Yeah, we should probably wrap up. But before we go, I wanted to say, despite my not being
Oh, can I say
fully,
one
yeah, yeah.
final thing about consciousness? Because I think this is something when I was studying integrated information theory, I came to this realization and it seemed really deep and kind of Eastern. So I wanted to bring that up. Um, Before I do that, I'll say one quick thing. I also want to mention that kind of goes against what I'm about to say, but I think about that a lot too. And it's like, suffering and consciousness correlated with like intelligence. It's more complicated as you kind of point out, but it's so complicated. For example, like humans suffer. We think like, that it's immoral for humans to suffer, but there are times you don't feel bad about killing an alligator if it's charging at you and it's so aggressive, like you just kill it and you don't feel bad if something's acting aggressive. And maybe that's messed up, maybe it's not. Um so when I thought about that, like is it okay to kill something that's like super aggressive and coming at you? Is it like suffering? Is it like is it morally better to kill something that's like aggressive than something that's like, not aggressive and kind of like, you know, a calm animal that wouldn't hurt you? And there are certain states that you can be in that are aggressive. Let's say you're just in a crazed rage. Let's say you find out something that just enrages you. Let's say someone murdered your kid and it's the most horrible thing you could imagine. But if like you see that, like you'll be in like a rage and you'll try to like immediately go and like kill that person. If someone shot you in the act or like stabbed you, the amount of pain that you would feel would be far less than in a normal time when you're in this super aggressive mode. You're like, and you can give people certain drugs so you can get, to decrease their pain. But my point is, an alligator or some sort of animal that may have this aggressive chemical profile that kills other things, like it might not be suffering in the same way. You could have a much simpler, less intelligent animal with a different chemical makeup that could potentially suffer more than a more intelligent one, just based on the fact that we are can be in different mental states where we don't suffer or feel pain. I mean, there's certain things that, like you said, like mental states you can be in, whether it's drugs or like an enraged state where you actually feel pain less. Like I see pictures of like cops and they're like shooting this guy with like 20 of the like shocking things and he just pulls them out. He's some big beast of a guy. And it's like his capacity to suffer, even when he's dealing with pain. I mean, even if they like shoot him or like stab him and kill him, like there's just an enraged mental state where even those people, some of them were like still trying to like kill other people, like not even trying to like, yeah, to like what they were still so enraged that they were like going, even though they were in pain. So I think it's very complicated as far as how much something suffers. But I do think there is a correlation between intelligence and consciousness that we can start to get a general understanding of what things suffer more than other things. But some things might be more intelligent, like an alligator, like a dog that's like whimpers, like really scared. Like it might have a state of mind where it suffers more than a coyote, like a dog bred to like love humans and to be like, yeah. So it's complex, but yeah, the last thing I wanted to say is with integrated information theory, it started making me thinking about like intelligence as a product of how many states, the number of internal states that you can access in your mind. And so let me make that, this is more abstract, but it's tangible too, like or it's precise. So like a simple bacterium that does chemotaxis, that's basically just this process where it swims towards food. If it doesn't detect something, it will just shake its tail randomly, like we said earlier. And if it detects the right chemical, it will just stop and feed. So it really understands two states of the world. So its world is kind of black and white. As more complex niches and species emerge, you get species that have all of these different mental states. So where that can only experience a few states of the world, human brains can experience, I don't know, billion, I don't think anyone knows, but like billions of states. You would have to do an integrated information theory, like analysis on a human brain at different scales. It's kind of, it's unsure whether, we can do this practically at all. But in theory, intelligence would correlate to the amount of states in your mental repertoire. And if you do that measure of integrated information theories phi of the integrated information, it would basically be correlated with, that the size of the mental repertoire. So right. Where an ant, let's say an ant can experience like 1,000 states of the world, a human can experience like, let's say like, a million or whatever, whatever it is. Instead of saying higher intelligence in this vague way, we can start to talk about the size of the mental repertoire. So if there's some sort of different things in the environment, you can respond to that, you can perceive it. But things with very simple nervous systems, they can't perceive it. You can shine, these different colored lights on something that doesn't have vision, and it's not aware of those states. So what I came to believe is that the amount, the intensity of experience, the intensity of a good experience, of an orgasm, or of a painful stimulus, must be correlated with the amount of possible states, because the information from one experience is measured by all of the alternative possibilities that it's ruling out. And that's based on Shannon's information theory. For example, like if you throw like a coin, it has a bit of information because there's only two states it can be in. And when you observe the state, you get one bit of information because it's heads and not tails. But if you roll a six-sided die, when you see the state that it's in, you get more information. There's more bits of information because you go, oh, it's a 1 and it's not a 2, 3, 4, 5, or 6. So there's more information if there's more possibilities ruled out. So if that's true, then there's more information in a single conscious experience for a nervous system that has a larger mental repertoire. And so the more things you can experience, the deeper you feel them. And it also shows that there's kind of this dualistic nature, this spectrum to where like you can't really have joy without having an understanding of pain. Like you have to have this spectrum of possible experiences for even joy to be meaningful. There needs to be a conception of pain. So that would give us a more technical explanation for what consciousness correlates with. It correlates with the size of the mental repertoire of the number of accessible internal states by a cognitive system. And in theory, that's what integrated information theory phi measures. And we can maybe do some proxy measure to get at a rough estimate of the number of accessible states. And that could potentially give us, at least for now, a rough map of which things are more conscious than other things.
I think that fits with Carl Friston's idea as well. He's written about of counterfactual depth. So he talks about the idea that
Yeah,
when
who
you're
Friston?
Carl Friston, yeah,
Yeah,
when you
yeah.
have a belief about something in the world that corresponds to a conscious experience, things become conscious when you can hold that belief and it's excluding a vast range of other beliefs, particularly within a time frame. He's talking about the
Yeah, I was gonna say because counterfactual depth is also about our ability to like look farther into the future.
yeah, like temporal thickness of modeling is how he talks about it.
Temporal thickness, yeah, and I think that would add to the mental repertoire of possible internal states. Now you have states that you can access that are about the future, where lower animals can't reason about what's going to happen 10 years or 1,000 years or 1,000,000 years into the future. Yeah, I think that's really important stuff. I'm glad you brought that up.
Yeah.
Yeah, because Friston's work is very complicated and you have minimizing, you have free energy principle, but then there's like concepts that people I think are really important that people haven't gotten into, like minimizing expected free energy, which is more about this like counterfactual depth and
Right.
temporal thickness. And I think there's a lot of value to taking those very rigorous ideas and then applying them to how we think about like real life. And no one has really done that yet because that literature is so complex that mostly it takes academics to understand it. So yeah, I'm glad you're talking about that kind of stuff.
Yeah, and so one final question when it came to mind when you were talking about the kind of nice idea that if you have to harm something because it's being aggressive, or maybe they're in a state where they don't feel as much pain, that it felt like you were kind of saying almost like, wouldn't it be nice if that was the case? It's kind of like a comforting idea. And does that instinct, like a lot of what you've said, sounds quite comforting. Like it's a nice, yeah. If you hold those beliefs, it makes the world seem like a nicer place to live in. Does that play any role in your? I think I'm of the belief that emotions play a lot of
Yeah, I mean,
roles in
it
our
always
thinking.
does. It always does. But that one specifically was after the fact. I was like, well, I was trying to understand. I mean, maybe at some intuitive level, like everybody kind of thinks that, dumber things have less of a conscious experience. Um, but no, I wasn't expecting it. I was really just trying to explain the hard problem. And the best solution that I came across seemed to be this self-modeling thing. Because first of all, consciousness, there's this story of emergence, and you get emergence by things interacting and something new coming into existence. So I think if you have an emergent, theory of the world, and you have this hierarchical, uh, organization process, that you have new properties that emerge at new levels, and that's what's amazing about evolution. If consciousness was there from the beginning, everything was conscious. I don't think it would be that special. What's so interesting about it is that we have this process that gives rise to agents that can experience the world. And then I'm arguing at some point the whole world becomes conscious. So I think panpsychism is not even as cool and psychedelic as what I'm saying. Even though some people might argue that this is a version of panpsychism, some people say, I've seen a lot of physicists say, I'm a panpsychic, but then when you press them, they say, well, I don't think everything's conscious. I don't think atoms are conscious. I just think they have the capacity to be conscious, to be part of a system that's conscious. And I believe that. I believe everything at some point will be part of this fully conscious integrated entity that is the universe. Um, but I don't think it starts out that way. And yeah, I had
The
another point, but I forgot.
So the one thing I want to say before we finish is, I'm not a convert to there's this idea of a mega point of saturation of technology throughout the entire universe. But full disclosure, the first time I tried DMT, I had the experience felt like waking up in the future where we are fully integrated with technology and everything is just this kind of perpetual increase in complexification, and that what we experience now is a kind of simulation that we go back into just as a kind of recursive loop for God knows why.
Wait, sorry, can you explain that again? I was hung up. Yeah, the point I was gonna make was that consciousness sorry about that. I was just saying consciousness emerges and from the self-modeling thing, and that was the best explanation. And then I saw that uh if that's the case, then you wouldn't have it below, and it was just kind of like a nice bonus that those lower things would be conscious. But please explain that once more. That's a good thing to end on. But yeah, that was sounding pretty trippy. So
where was the DMT trip? So it was first time I tried DMT, and it felt very convincingly like I'd kind of realized the structure of reality was basically what you're describing. And I don't think this is accurate to really what's going on, but it really felt like I woke up into the future where we've reached this omega point of technological saturation, and we create simulations of the past where we go into them to kind of pretty much take down the energy, because we've reached this kind of ecstatic crescendo of kind of well-being maximization through integrating ourselves into technology, and that we're just stuck in this kind of loop of ever accelerating kind of takeoff, both subjectively and in terms of.
And why didn't you like that? Why didn't you find it convincing? Just because you're on drugs?
I mean, it was quite earth shattering. It gave me what they call ontological shock, because it felt so convincing. But then I tried DMT a few more times. It didn't replicate, and other people's experiences aren't the same. People have weird experiences. So the lack of consistency was the main thing.
I do think psychedelics have the power to reveal deep truths about nature, just because you're disengaging certain lenses and you're seeing a more complete picture of reality. But yeah, so I understand.
You can a glimpse beyond the veil.
Yeah, and the fact that kind of psychedelic experience and there's just states of mind you don't need with drugs, but you can start to cultivate that kind of thinking. I think that does bring people closer to this story of the universe as a self-organizing system. And to me, that I think that makes it more convincing for me, because I think psychedelics are kind of part of the whole system, and that basically biospheres produce psychedelics as part of this process of intelligence becoming more self-aware, which is kind of far out. There's a book called Darwin's Pharmacy that's great, that pretty much argues that.
I've interviewed him a couple of times on the podcast.
Oh yeah,
Richard Doyle. Yeah,
he's very cool.
He's a great guy.
So I would just say, as you said, we're all influenced by our biases. Don't discount that idea, because I feel like I've seen multiple people do it, and a lot of it is kind of based on an affinity for certain like Eastern practices, like integral theory, like Ken Wilber, who I've learned about, has this whole story of complexification. But he argues that, and he even argues that it's going towards a mega point, but he's like, that's not the end. It'll just keep doing it forever. And there's cycles forever. And that's samsara. And that even this good story of omega point is still like, you want to be released from that cycle. And other people have, are attracted to this idea of impermanence, like going wabi sabi and different Eastern philosophies that where, everything, you have the cycle of living and death and you can find satisfaction aesthetically in those too. But I just think that if it were kind of like all random in that way, I find it hard to believe that with a sample size of one, it would be very strange that we seem to keep crossing all of these barriers. Because if it was just kind of a statistical thing, we would just stall. You would see all these biospheres that stalled at different points, and you would see some that maybe get a little bit better. But I mean, the farther you get in that story from the old view, the more improbable that would be. So I just think it was never improbable. So if anything that I've kind of wanted people to think about in a serious way is that maybe the universe is kind of like an AI or a neural network, and like life is just this thing that's being trained, and and thinking that there's so many possibilities of ways that it could go is part of what we need to do. We need to understand that counterfactual space to actually, move along the trajectory that we need to. But it's not at all against naturalism to think that things are moving towards these attractors. And that's all that I think this process is a series of larger and larger attractors emerging, because there's these dynamics that are left out of the normal reductionist story, where it's not just particles bumping into each other. There's actually this sort of deeper dimensionality to it, where you have these attractors, where you have not just everything moving these random trajectories. There's actually a clear trajectory towards components, nature's fundamental particles coming together to make ever greater wholes. And so if that's your new naturalistic story, that's just how nature is. And then you get all of these crazy ideas, like basically gods that emerge, self-aware universes, but it's not a non-naturalistic story. It's just a new story of nature. Yeah.
Right. That's great. Thank you so much, Bobby. This has been really great. This has been the longest podcast I've recorded in a while, so I really appreciate it.
Thanks. Hopefully people enjoy it. I loved all the questions. I didn't sleep well last night, so I lost my train of thought a couple of times.
No,
but
you did great.
I really appreciate this.
Yeah. And would you, I guess you point people towards the book, Remnants of Reality. Is there anywhere else you'd point people to?
Yes, the Road to Omega Substack and YouTube channel. The Substack, I'm really that's where I'm publishing stuff that's going to be in the next book that kind of takes these ideas and applies them to life. We didn't talk at all about like how this informs life. I think you can actually create a self-help system from this. I call it the teleological stance, but that's basically that life has this cosmic purpose to perpetuate life. And if we want to do that, we need to live optimally as individuals. We need to optimize our social, political, and economic systems based on these evolutionary mechanisms and cybernetic mechanisms. And this complexity science picture gives us a roadmap for how to optimize those systems. And the fact that we haven't really made like analyzing networks for like thermodynamic efficiency and stuff, like looking at these human systems as these statistical systems and modeling, human civilization. The fact that we haven't done that, we're going to look back and be like, wow, we were still in the dark ages. So, the Substack is about taking these ideas that are very abstract and theoretical and applying them to improving your daily life by like optimizing your own model, making sure you're like approaching the world like, curiously and skeptically, but keeping your mind open. So this kind of like Bayesian reasoning, like basically I want everyone to kind of use Bayesian reasoning in daily life, and improving society, and this kind of like understanding that spirituality and science aren't incompatible, and that getting rid of all of the practices of like meditation and the rituals of religion is throwing the baby out with the bathwater. Those things emerged because they were adaptive and they still exist because people find them very useful. And so science is hurting science by being like, yeah, that's all bull crap and no one should do those kinds of things. The more science opposes those kinds of practices and rituals and thinking about, lives as having purpose and meaning, that's just keeping organized religion strong and in the world, and ideological religion. So science needs to start moving towards like, merging with spirituality if they want to fight the harmful things about religion. So that's what the Substack's about. If you become a founding member, which is like $100 subscription, I'll send you a signed copy of The Romance of Reality. And yeah, I'm just going to be super active with like publishing YouTube videos and doing interviews. And I'd like to interview you sometime in the next year. And so people can follow those channels, and there'll be a lot of content coming soon.
Yeah, that'd be great. I'd love to be interviewed by you.
That'd be awesome. Yeah, the living mirror theory of consciousness. Yeah, it's very cool. We got to discuss that. And psychedelics. I'd love to talk to you more about psychedelics as well.
Absolutely, yeah. All right.
Thanks,
Bobby. I appreciate it.
Take care, James.
Thanks for listening. If you're watching on YouTube, please like and subscribe. And if you want to help the podcast reach a wider audience, you can leave a review on Apple Podcasts. Finally, if you want to offer financial support, you can go to patreon.com/Dr. James Cook.